Pause. All right, folks. Whoa. We're going to get started in just a minute here. This is TLS Working Group. If you don't intend to be in the TLS Working Group, then ought to find another working group.
All right, let's get started. This is only Tuesday, so you may not have seen this a lot. This is the note well. The brief summary is basically this is just to kind of point you in the right direction. The idea is that participating in the IETF, you agree to the following processes that are all listed there. If you're contributing something, write or say or discuss in the IETF context and it's covered by patents or patent applications, you need to disclose that fact. You are going to be recorded. It's in the whole room. It's meet echoed. It's out. It's recorded. It's out there forever. And if you want some more details, it's there at the back on the last bullet there. Requests. We actually already have a minute taker. Thank you very much, Jim. We already have a Jabber scribe. Thank you very much, Rich. Please sign the blue sheets. They're going around now. Some reminders too is just to state your name at the mic for the scribes and minute takers, and let's just keep it professional at the microphone. So here's our agenda now. We've done the administrivia stuff. We're going to do kind of a quick status update of all the drafts that are floating around, and then we're going to kind of get into the meat of it, and that's primarily TLS 1.3, DTLS 1.3, then some other stuff like the Dane records, certificate of repression, and delegated credentials. The last two are not in the working group yet. And then the third one is we have a bunch of drafts that have been waiting in the wings for TLS 1.3 to get done, and we're going to try to figure out what to do with those. So it's going to be really quick. Here's an abstract. Have you read it? Are we thinking about adopting it? So document status. Since the last meeting, we did adopt 2 drafts. Thank you very much. Example handshakes, which is going to be revved infrequently, i.e. maybe one more time, and then we're going to be done with it because it's going to reflect the last version of the draft. The Greece draft too, I think there's not really a whole lot more to do, so that may be going through fairly quickly. I'll need to talk to David Benjamin about that. We got the elliptic curve stuff for cipher suites for TLS 1.2 and earlier is now, the last version I believe was addressing some ISG comments and some late comments from Ecker, so we should be done with that fairly shortly. And moving RFC 5289, which is like the ASGCM cipher suites from informational to standard track, completed. 1.3 has gone through 2 working group last calls. I don't believe there's going to be another one.
Regarding the 4492 BIS, it went through rather big changes during IETF last call, so Stephen wanted the group to just have another look to see that everyone's okay with the result.
We can do that. It's pretty easy. We can do that. I guess we had another cipher suite draft that actually already also went through working group last call. So I guess we're just waiting to get Shepard write-up, and then we're going to push it towards our new area director, who I believe is Kathleen. There she is. Hey, that's Kathleen. She's our new area director because Stephen is cycling off. Is Stephen here?
We will be in a minute. I just saw him.
Okay. Like I said, we still got 2 other drafts that are in process, which is the Dane record draft, and then a draft that I'm writing. So that's something Kathleen has to run. It's an IANA, Joe and I are writing. It's an IANA registration update. Probably the biggest thing in there is that we're adding expert pools, I think, to some of the things, because Ecker is going to be our area director, or be an area director, and we need to lighten the load. So we're going to set up a pool of designated experts. And then we have a bunch of drafts patiently waiting. DTLS 1.3 is probably at the top because it's not yet a working group draft, but we need to start that process. I guess we started it last week. And then there's a bunch of other drafts. The list is actually quite a lot longer than that. These are just the 4 that have been there waiting, and those are the 4 drafts that we're going to talk at the end. Without further ado, Eric, you're up. Don't forget the pink box.
I didn't see bottles, so.
Howdy.
Oh, hey, so just before we get started, we're going to do the whole handoff of the area director thing. Hey, Steven, don't go too far. We got you a present. We know that you love to drink some beer, so we got you a cooler full of a six-pack of some ice.
Speech.
They're bottle openers.
Yeah, every time we say a 0 round trip, you have to drink a beer. Right. Wow, I do go fast, but not that fast. So I did these yesterday, so I'm not sure what they say, but we'll see how it goes. This slide is already wrong. Next slide. Right, so where are we? We had a working class call that turned up some small issues last time. That was on draft 18. I processed those in some not entirely dilatory manner and got out of draft 19. I'll go over the changes that we made, which I think are essentially pretty modest. We have quite a few interoperable implementations at this point. So draft 18 has been fielded pretty extensively at this point. So Cloudflare is already running it, and all Nick can clarify the exact terms, but a very large fraction of their services, I believe, is the right way to phrase this. Facebook now has an endpoint up, as does Gmail, and these are all 18, of course. And then both Firefox and Chrome have have default on support for 1.3.18 in beta, and have support which you can flag, but is not default on in release due to fighting with some middlebox people. But hopefully we're going to win that fight soon, so we'll be actually turning on. Most of the major stacks now have some level of support, either landed or ongoing. So NSS release has 18, and we're working on 19. I believe OpenSSL has 19 in trunk. I don't know if they have a release version yet with, I see head shaking. I don't think so. It hasn't made a release. And I don't know if Boring SSL does releases, but they have 18 in, as far as I can tell, master. And then there's a pile of other stacks that are probably less well known, though. I guess it's worth mentioning that Facebook and Cloudflare both have their own stacks that also do 18. That's what those live endpoints are running. I think people by and large felt that this changes in 19 were small enough that it was better to get deployment experience with 18 than sort of have to fight with the 18-19 split. So people have been a little dilatory about doing 19, but we now have implementations of, I think, essentially every major piece in interop for some of them. So I don't think there's any real concern that those pieces don't function. That we found a few places where we did interop that there was disagreement about. There was unclear specification language, but in general, we were able to resolve those in ways that I think everyone agreed on what it should say. It just didn't say that. So I think people are feeling pretty good about that. Next slide. So I'm just going to go through the changes we made. Trevor Perrin pointed out privately that there's an oddity in the key schedule where we don't have where with HKDF is designed with this extract expand design, and we were doing successive extracts. So we do basically extract to mix in one key and extract to mix in another key. And that's not really how HKDF was supposed to be used, but we talked it over the cartographers and they seemed okay with it. And Trevor pointed out there was this odd case where if you could really control the key that went in, then you could force some sort of quasi collision between basically the key that popped out of an extract and the key that popped out of a derive. And it wasn't clear you could actually do anything with this, and it didn't seem like you could actually make Diffie-Hellman as currently is do this, but there might be some, we also don't have a proof of that, and there might be some other cipher suite, other key exchange mechanism where you could, so it seemed better to fix, and also that get us closer to the fair way of how Hugo designed HKDF to be used. So the fix is pretty straightforward, which is essentially we add everywhere on the input to every extract that actually has a key going into it. We put a derived secret stage, which is really just an HKDF expand, and all this does is basically break the symmetry between the right side extract and the downward expand. The right side expand and the downward extract. This is, as I say, a really straightforward change. It's about 10 lines of code in NSS. I think it was a similar, I'm talking to other people. It seemed relatively harmless and made this problem go away. And then, as I say, got us closer to the fairway. So unless somebody objects, this is staying around. By the way, essentially everything here has been circulated in the mailing list because we're operating in a mode now where I don't land anything major or pretty much anything substantive without circulating the mailing list. So I'm assuming these things have consensus, but I know some people don't read the list, so I'm going over them for abundance of caution. So now's the time to yell if you see something, but I'm not going to stop for like consensus hums after each thing because these things already have consensus. Next slide. Right. So this is actually a small defect we found. The exporter API in 5705 is defined as taking an exporter that taking a context string that can be quite long. So the context string is, as you'll recall, an exporter takes a label, which tells you what you're using it for, and a context string, which is intended to be used as a binding to some sort of external thing. Now, to my knowledge, nobody actually uses the context string, except that we started thinking about using it, I believe, in some of these external authentication cases to tie, for instance, to the certificate you're attempting to export for. And so in that case, so since the API allows quite a long context string, however, when we did the port of exporters to 1.3, we basically just mapped the context to the hash value thing in the HKDF expand, and the hash value thing, because no known hash is anywhere near as long as 255 octets, just like has a 1 byte length value. So that means if you have a super long context, you have to figure something out to do, and it makes the API gross. So the fix here is just to hash the value before feeding it to HKDF in the context. I mean, this is not the only way to do it. We could have left it as it was and said if you want to do something longer, you have to hash, but it seemed easier to make the API better, and it also avoided the goofiness of passing something which is not a hash to hash value. So again, a straightforward change. Can I go down one more? Right. So remind me to go back. This is another nit. Martin Thompson pointed out that the way that exporters are constructed, that say you have a situation where you're doing where you have a single TCLS connection and you're deriving two sets of exporters out of it. And the first exporter, for instance, is used to generate traffic keys. And the second exporter is used for subsequent post handshake authentication, as in Nick's additional authentication draft. So the situation here is because the exporters are both pulled off the same secret, you have to hold the exporter secret around for a while. So if you ever want to do this post handshake authentication in HTTP, then you also have to have the same key you use to generate the traffic keys. Now, it's not actually clear how this causes a real problem again, because these are kind of fate shared. But Martin pointed out that there's something simple you can do which makes this problem go away, which is if you know all the possible kinds of exporters you're ever going to generate, then what you can do is you can basically add one more secret to the cascade, one more derivation to the cascade that basically derives sub-secrets for each kind of exporter, and then you can derive each of those separately. And then what you can do is so in this case, what you can do is you say, well, I've got the exporter I use for the traffic key material, and I do that, I make the traffic keys, and I throw that key away. And then I separately generate the exporter I need to generate the authentication bindings, and that I hold on to. And so if that ever gets compromised, it doesn't threaten the traffic keys. That sort of made me sad when Martin pointed it out, because I was like, gee, this is like a big enough diagram already. But then we talked about it, and I realized that we could just stuff this derived secret in the first function call, and it basically looks the same, and it's just another thing in the line. And since I was mostly concerned about how much ASCII art I had to do, this seemed like an improvement. So we did it. And so the point here is no one's making you do any kind of multi-stage storage. It's just a function you compute here. It's a slightly more complicated function, but it's straightforward. But if you want to do multi-stage storage, this enables it, whereas you couldn't do it previously. I don't see anybody twitching. So again, we did surface this in the list. Okay, can you go back one slide? Right. So not much text for a change that caused actually a fair amount of angst. And is actually a big pain to implement if you actually have an implementation of the kind we have, and has forced me to do some cleanup that David Benjamin suggests I should have done quite a while ago. Basically, you recall that there's a hack for hello retry request that allows you to basically do a stateless hello retry request, and the technical issue here is that the hash transcript has to be maintained through the client hello HRR, client hello 1 HRR, client hello 2 cycle. And so what we realized quite early on was that on the client, this is easy because the client maintains state. But if the server wants to, what the server can do is he can take the hash state and he can basically offload it to the client by stuffing it in a cookie. And we realized this pretty early on, and that's all fine. But that value, the size of that value is dictated by the size of the state you have to pickle. And in a conventional Merkle-Damgard hash, because basically what you do is you operate in blocks. And so you have you have the hash state itself, which is typically the size of the output hash, the output of the compression function, currency of the compression function. And then you also have whatever block remainder you have that happens to be associated with the things you haven't hashed into the compression function yet. And it's also the case that that's generally quite a bit bigger than the hash size. And especially for like SHA-512 and SHA-384. And depending on how you implement SHA-3, it's either much bigger or or more or less the same, though convenient implementations would be much bigger. Also, it's not a standard feature of sort of hash function APIs to let you sort of export a partial state for hash forking. It's often common to let you fork the hash, but it's not common to let you passivate it into like a serialized string. And so to give you an example, if you look at like the way NSS does this, NSS has this function, but the size of the block you export is like truly enormous because the working size, it uses the same, this is just inside baseball, but it uses the same buffer for the stored remainder as it uses for the working state of the hash. And so when you ask it, and even though at every block boundary that extra 48 octets gets basically zeroed out, and so basically when you ask NSS to export like the hash, it's like 256 octets, and it's really ridiculous. And I spent a lot of time figuring out how to try and shrink that, which is just programming, but like it's still programming. So David Benjamin pointed out that this could be simplified, and I think also Antoine Delagneau and Cedric Fournette pointed out this could be simplified if we said that basically that instead of in the special case of client hello and the client hello HRR cycle, what you did was you basically hashed the client hello and then re-injecting the transcript as if there was a hashed value instead of the client hello itself. And in order to simplify this, now this gets a little complicated if you don't know in advance which hash the side is going to choose, but the way the negotiation basically has to work is that the server has to already pick which cipher suite and hash it's going to use anyway. So in order to clean this up, basically what we did is that the hello retry request, first of all, the hello retry request contains the cipher suite that the server has selected, and then what the client does, he takes that hash function, hashes the client hello, and then re-injects in the transcript as basically a phony handshake message with a special content type. So it's injective. And then the client's supposed to check that the cipher suite matches, though I don't actually think that's required. I think it would actually be fine even if it didn't. As I say, this is basically, it requires a little bit of fiddling, but it's not particularly difficult if your implementation is constructed correctly. This is probably the biggest change that sort of has any kind of level of controversy. Again, we did get consensus on the list, but I just want to make sure people aren't like totally done about this. Okay then. Right. Someone, I can't remember who, pointed out that we have exactly in every other point of the protocol, we do state transitions for keys on handshake messages. But there's one point in the protocol where we do a key transition on an alert, and that is end of early data. And so this is a battle between two forms of consistency. Form of consistency 1 is end of early data marks the end of data, alerts mark the end of data. And form of consistency 2 is key changes happen on handshake messages. We went for form of consistency 1. I think that was ultimately wrong, and I was persuaded to do form of consistency 2, which is that we should make end of early data a handshake message rather than alert. That really doesn't make that much difference. What it does, however, mean is that the end of early data goes in the transcript. And that was actually, so that's both the motivating reason why we did this, but also a form of some confusion. The motivating reason is it makes absolutely clear the order in which events have to occur in the handshake. Because once it's fed in the transcript, then it makes clear that the server hello has to be processed before EOED is processed. So that means that if you screw that up, like, so it's historically been a case that if you screw it up, you get deadlocks. Now if you screw it up, you get like handshake failures, which is at some level better. So that's good. One difficulty is apparently the person doing this writing wasn't able to write clearly enough, wasn't able to find all the places where it referred to EOED as an alert. And so when you read the specification, none of these points are like entirely clear. And so we have two implementations now, one of which decided that EOED, I think, should be hashed before server hello, one decided it should be hashed after server hello, or server finish, sorry, not server hello. I think everybody agrees that the right answer is the one that's on the screen, namely server finished EOED and then whatever the hell the client sends after that. It's just that people are trying to conform to the spec and the spec was badly written. So can someone close the door, please? In any case, I moved some stuff in the spec around and made this point clearer, and I think everybody agrees. And as far as I know, everybody's already updated their 19 implementation to behave this way. So we now have interop between the implementations, which were confused about it. And to my knowledge, every 19 stack now does this. That does this at all does this. Okay, next slide. Right. So we had 3 outstanding PRs, and I proposed dispositions for these in the list, which, in the spirit of being done, are mostly don't do anything. We had this extended discussion about reuse of Diffie-Hellman shares. Yoav had suggested this sort of backhanded way of dealing with that by saying, I think it was you, maybe it wasn't, it said, if you do reuse Diffie-Hellman shares, here's what happens if you reuse them. And there's a PR for that. And so I'm not ultimately opposed to this PR, but my concern with this PR is that none of the available security analyses for this document actually assume that Diffie-Hellman shares on the server are reused. And so it is trivially possible to build protocols which are secure without Diffie-Hellman reuse that are not secure with Diffie-Hellman reuse. The intuition people seem to have is that TLS 1.3 is still secure if you reuse the Diffie-Hellman share, but we don't have analyses or proofs that show that. So the behavior that this text suggests and that you'd like to have would be that if you reuse the server's Diffie-Hellman share, you just don't get PFS. But we don't actually have a demonstration that's the case. And so absent that, I'm kind of uncomfortable with the draft actually saying that's the case. If someone pops up with analysis, then suddenly I'd be much more comfortable saying that. But since we don't really want people to do this anyway, I don't see a lot of, I'm not really excited about having this material in here. If someone feels strongly about that, now is the time to speak up. To be clear, we don't mandate that you do not reuse Diffie-Hellman shares. We just don't say anything about it, but we certainly don't encourage it either. Okay, Martin, can you close the PR?
Yeah, Martin Thompson. I can't close the PR, but I endorse doing so.
Okay. I've forgotten you can't close. Sean can.
I have the power.
There's the power. Okay, next slide. Right. So we had this extended discussion about short headers. As everyone who's been following this knows, we have 3 bytes of complete waste in the encrypted packet header. And we know how to remove it if we only didn't have to worry about anyone else in the world, anyone else's network. Unfortunately, so the situation is, and I promised to do some experiments to have, though they're not as convincing as I was hoping, but initial data has suggested that that middle boxes are already somewhat sad about TLS 1.3, and we're going to spend a bunch of energy making them less sad, and that they're substantially sadder about this. And my initial data, though I wouldn't call it scientific proof, suggests that one of the ways in which they're sad about this is they just stall. And that's much, much worse than they just send you an alert, because then even the goofy mechanisms we have for dealing with failure to support 1.3 don't actually work properly. And so while I would very much like to remove these 3 octets, and I think other people would as well, my sense is that everybody's kind of abandoned that thought as well, and no one wants to press that point. I think I've talked to everybody who wanted to do it, and they've now come to that conclusion. If I'm wrong, now's the time to speak up. Let me say first that this does not mean we can't drop them for DTLS. We absolutely shorten the DTLS header, which is already much, much longer than it has to be. And I don't think anybody does much DTLS inspection, so I don't think there's a problem with that. So later I'll be talking about shortening the DTLS header. I may be wrong about that, and we may end up with like 15 dummy bytes, like I see Adam looking at me. But I think there's a better chance we're going to snake out with that one. Partly because many of the uses of DTLS involve things like ICE, where people just are willing to tolerate a much higher error rate than they're willing to tolerate for TLS. So if anyone thinks we should continue to pursue this, now is the time. Okay. Finally, it turns out that basically all the documents that describe how to use alternate non-509 certificate formats kind of just stomp the entire certificate message. And that seemed like kind of a credible idea back when the certificate message consisted solely of the X509 certificates. But unfortunately now it consists of other stuff, including extensions and certificate context and whatever. And in particular, the extensions are associated with the certificates because that's how you carry, for instance, SCTs for multiple levels of the certificate stack. And so it's not, so it's not the case that you can just say those extensions which stomp the certificates continue to work properly. And it's not the case that you can just sort of say, now maybe there's something we could write that would be I don't know what we'd write, to be honest, because basically the structures are all different and not all of them are structured as chains and that kind of stuff. My general impression is that none of these have enough uptake, with the exception of user mapping, that breaking them is a big deal, and those people can write new RFCs when they're ready. So saddening though it is, what I propose to do here is take the following 4 or 5 extensions, and I'll get to that in a second, and put them in the not allowed in TLS 1.3 list. And then when people write new RFCs, they can do code points. The exception to this is cached info, hence the question mark. Alara Losvara points out that if you think of cached info as covering the entire certificate message, which is a little difficult because we have the because they have the context, but I think we can fix that by just excluding the context. If you think of it as covering everything but the context, then it actually is sensible to think about that as one giant block. And so we might be able to salvage cached info, but we might not be.
Hannes, so the cached info is a more recent work. So obviously it always takes a little bit of time to get the stuff deployed. But for the cert types, in case of it covers a couple of different cert types, so that deployment situation is different for those. I don't know about the OpenBGP stuff, but the raw public key one is something that we use in the IoT environment.
So I think the raw public key one is probably the easiest to fix. The raw public key one, we simply say that you must have exactly one raw public key entry, and it just replaces the SM1 cert. So I guess I can see people lining up, so that's great. I guess what I would say is, if you were the author or a proponent of one of these drafts and you would like it to survive, to not be in the off list, your obligation is to very quickly send me a paragraph or two, which I can put in the document, that explains how to use the damn thing. And I don't think I think those are straightforward enough. We could probably just call for a consensus on those things on the list. So I think that would be my post resolution for somebody who cares about one of these things. I just don't think we have the time to spend spend the next year trying to figure out how to make that work.
Yeah. So Martin Thompson, I was getting up to ask about cert status v2, which I think
we should. It's already banned.
It's already dead. The other thing is the context is 0 length in the handshake, so you can just include.
Oh, you're right. Thank you. Quite right. Good point. So compression will work. We just have compression survives as is. Sorry, cached info.
Victor Vassiliev, Google. I think we discussed cached info when we originally introduced the change, and the conclusion was that it can just work as is. And with regarding to certificate types, we should just go through them and decide which of them are viable and drop a paragraph, and that should fine. They either go into leave what's in the either the leave field or the entire or they replace the entire. So we just described interaction.
Because currently the cert types are X509, OpenBGP, raw public key, right? That's it. There's somebody who's trying to define an extension with 2 other certificate types.
Well, they can conform to us.
Yeah.
So I guess my question is, I see I see Hannes and DKG in the line, and I'm wondering if you guys could manage in the next week or two to provide me some text that would tell me what to do about those two types.
I think I will.
So this is DKG. The only current implementation of OpenPGP certificates is about to deprecate them and remove them. So
Oh,
Yeah,
so-
I've already said that on the list, yeah.
so
So we don't need to solve that.
I mean, I'll look at it and see if it's something that makes sense to solve, but I think dropping it is probably fine.
Okay. So Hannes, maybe you and I can get together and figure out how to solve for all public key. 'Cause I'm happy to keep these. I just don't want to hold the specification for them. It's basically where I am with that. Okay. Great. I think we have a resolution for that. I'll try to get some text by end of week. I'm very motivated. Okay. So this is my last TLS slide. Of course, I have like 97 DTLS slides. So we had a lot of back and forth about post handshake client auth. This is the latest attempt, the latest sally by someone. I'll let you read it yourself. So the issue here is that it's somewhat annoying for the client, for a client who doesn't want to do post handshake client auth to engage with servers who want it, who in principle want it, because basically the server offers it and the client is supposed to do something, or maybe not supposed to. The specification probably isn't as clear as it should be. I actually don't think it's unreasonable for the client to simply, the server has to be prepared for the client to take some time to handle it. And so I actually have no problem with the client merely ignoring the message entirely. Anyway, Olivier raised this. He listed a bunch of options. I've crossed one off. We had consensus a number of times to do post handshake client auth, so I don't think removing is on the table. So like unless someone's gonna like fight that, I'm not gonna argue that on this set. We've had repeated discussions about these remaining three. I do agree it's modestly annoying to deal with this, but my proposal we do nothing. But I'm handling issues as they come up. So I guess I'd like to hear what people think, so we can close this issue. I guess these are in reverse rank order for me. Namely, do nothing. Say explicitly you can just camp on the connection, and which I think you already can do, but you could say you could just camp on the connection and not respond, or require extension opt-in. Those are my reverse order.
Hi, this is Hannes. So even before the message was sent pointing out that this requires additional, or the implementation of it requires additional memory, since I haven't implemented it, I obviously didn't realize that. In our use cases, we don't. I think this is a browser use case, pretty much, and it doesn't occur in at least in any of the IoT use cases I've seen. So from that point of view, it's a little bit unfortunate. You have less memory, and then you need to deal with this issue, which is that's why I was either to have an extension, as I previously argued, or ignore it. But I understand that most people here want to use it in a browser context.
So I would, by the way, expect removed from DTLS. For it's worth, I expect this not to be in DTLS. I don't know if that makes you feel any better, but because as you say, this is a accommodation to existing use cases, not something we're trying to go forward with.
Andrei Popov, Microsoft. I have a question for people who are worried about the extra memory use. I believe the client is always allowed to send an empty certificate message in response to this. Does that solve the problem, or?
No, because it needs to generate the finished.
Oh, okay.
But I mean, to be clear, the extra memory usage is the size of the hash state that you were willing to send, that we previously, until like draft 19, you had to send back over the wire in the HRR. So I'm like actually not like, I kind of feel like people who can't spare 512 octets, like I don't have like enormous sympathy for those people.
Well, in this case, I think it would be okay to negotiate it using an extension, for example. Yep.
Okay. Do people want? I think that would make several people happier. If it doesn't make you sadder, I think that would be a reasonable approach. I thought that made you sadder. That's part of why I was resisting it.
Yeah. So Martin Thompson, I think the onus is on us to take a few extra steps in this case to accommodate the small devices that are going to be implementing this protocol, and making it simpler for people to implement the protocol. And I think where we can shave off those things for those people, that makes a bit of sense. And
so the proposal is to have essentially an empty extension that says I will do post handshake line off, and if you don't send that, then you don't.
Yes, and that would be a very simple thing to specify. I'm happy to write a PR for that if people think that's acceptable to them. And we solve the problem for everyone. I mean, it's more options in the protocol, which I always hate, but it's also something that I think we could benefit from. It's probably worthwhile in this case.
I'm not going to fight that.
I think I agree that the extension is a good idea. I also think it's a good idea from the perspective of you may have a lot of clients, some support it, some do not. And it's much better when you're looking at, say, having a new use that you turn this on to actually know explicitly who is going to support this and who isn't.
Right. So I guess one argument in favor of that, just to buttress that, is that if you're the implementation if you're an implementation which relies on this functionality, and then you try it and the person says no, now you're actually kind of in an annoying state.
Eric Dagrin, one possible use case also for the extension, I haven't fully thought this through, but might be for cases where clients or servers implement post-client, implement renegotiation for TLS 1.2,
Right.
but don't yet support it for post-client handshake auth
Right.
in TLS 1.2.
Oh, they might choose
Might
1.2.
allow them to choose 1.2.
That's a good point.
To avoid having.
That's a good point. Okay. Hearing rough consensus for extension and no arguments against, I will adopt that, and either Martin will send me a PR or I will write one shortly. Thank you very much. That brings us to the end. Allow. So that brings us to the end of next slide of the issues. Ben Caddick kindly sent me a whole pile of comments. As I said this morning, I skimmed through them. Do you have a? Oh, okay. I'll finish with what I was going to say about Ben, and then you can go. Then you can abuse me.
I was checking out, and I noticed that we have about 16 different derived something and HCF extract streams,
Yes.
which are not consistent in. Sometimes they match what they actually extract. Sometimes they are different, and there should be no, plan how they are actually, what are the strings? They seem to be random, and there is actually some string that are used twice, and most of them are once. And should they actually be, some kind of plan there?
Well, we did have a plan.
And they're actually quite long.
Huh?
They're actually quite long.
They are quite long.
300 bytes of the.
I mean, these are 64
strings that can't be.
Well, these are 64 octet, these are 64 byte block hash functions. So generally, it doesn't actually cause you too much static. They are quite long. They weren't intended to be random. The intent was that every use got one string.
Except derives. So there's one that is used twice.
Yes, the intermediate derives are now used twice, and we convinced ourselves that was okay, and it was annoying to have an extra string, so we didn't do it. I guess if you have a concrete counter proposal for how these strings ought to be adjusted, I would be more than happy to take a look at that.
I was actually also thinking about having table, listing. Actually, now there are actually one picture, most of them.
Yes,
but not all of them.
So I guess I'm not sure I understand. Would you like to change them, or would you just like better documentation?
I was thinking about it. Actually, I would actually like them to be shorter and have some kind of consistent plan for each of them. But that's just and if changing them causes trouble, then don't. But
it's only mental overhead because only mental overhead to change them.
Most of them are here, but
yes.
there is half a dozen in other places also. So
yes,
the K and IV and extract and whatever.
Yeah.
And there is like the resumption master secret is same that resumption master secret, but then the exporter secret isn't same as an exporter master secret. So there's.
I see your point. Yeah.
I was just thinking about it to be.
Yeah.
Easier for the
Sure.
implementer to be.
Yeah. So
consistent.
well, conveniently, this one is fixed by changing the word master here to master. So it doesn't require any wire change at all.
And the other one, the previous one is secret server traffic secret 0 or server application traffic secret. And I mean, just.
Well, so I think we attempted to be consistent, but if you have a set of consistent changes that you think would make things more consistent, I don't think that would cause anybody any hardship to change those strings in some way, as long as the property of the amount of uniqueness did not change. I will make a pass through myself, but if you have specific changes, I'll be happy to take a look. I I think no one has strong opinions. It may have been. Well, I will certainly fix that to make that called exporter master secret instead of exporter secret, which, as I say, doesn't involve any wire changes, just requires renaming a variable. Okay. So as I said, Ben Caddick had sent me a bunch of comments. I skimmed through them. They all appear to be ones which I didn't think anybody was going to argue about. So I will probably just make a PR for the ones I agree about and leave it at that. And people will have an opportunity to review that. I believe, based on the discussion we've had so far, that nothing we've discussed requires another working group call. So my plan is to, while I still remember all this stuff, to produce a 20 and send it to the working group. As I say, it sounds like a couple things that need PRs that people should at least sign off on and make sure I didn't screw something up. And I'll produce a 20, and then I expect the chairs will want to advance that to IETF last call or to the ISG.
So I don't think we need another last call.
Okay.
Right. Are there any other, issues people are sitting on, or?
Oh, no, I found that one. Thank you. I just had an interstitial. Okay. In terms of, I don't have this on the slides, but in terms of implementation, I think what's gonna happen is, my sense is that that while we sort of work out a couple of these last minute interrupt and crappy network issues, people are going to kind of camp on 18 for a while, and then I think everybody will sort of mass upgrade to 20, and but we're going to try to beat up on the middle boxes for a little while first. David Benjamin is kind of doing much of that beating up on, so thank you very much. I'm also going to, before I talk about DTLS, I'm going to take a point of personal privilege here, and I want to thank everybody who's just pitched in on this. And I thought about naming some names, but there are just too many people to name. But I think I've been amazed at the outpouring of people willing to work on this and spend their weekends before IETF and go to meetings and stuff. So it's been really gratifying, and so I really want to say I appreciate it. It'll be probably my last time talking at TLS in this meeting for a while. So thank you very much. There's a whole pile of people. Oh yes, there's a whole pile of people on here who did an enormous amount of stuff. If you think you should be on here and you're not, it's my fault, but it's your job to fix. Send me a PR.
There are people not on that list who didn't contribute to the document, but nonetheless contributed in other ways.
Yes.
That also deserve thanks.
So yes.
Point that out as well.
Yes, absolutely.
People are implementing, people are testing this thing.
Yes.
Are,
and so, there was no, this is a long list, but it is not an exclusive list. And if you, if you feel you should be on this, or you feel somebody else should be on this, by all means, send me a PR adding their name. And if there's any justification whatsoever, we're going to go on. I may try to make it double column. Okay.
All right, cool. Yeah, so I guess that's fantastic. Going on the DTLS.
Okay. And we're running a little behind, but I still think I'm going to do my usual pace. Right. So I think everyone realized I initially had aspirations that DTLS 1.3 would actually be in TLS 1.3. Unfortunately, the whole job turned out to be a little bigger, and so as usual, we had to do some keep cut stuff. And so DTLS got cut from 1.0 to 1.3. Luckily, we did manage to bring DTLS and TLS more into harmony, so this should be pretty easy as things go. So this is joint work with me, Hannes Scheffenegg, and Nagender Motodugu. Hannes did quite a bit of the initial work on this, and next time I'm going to make him do this. Next slide. So state of play is, this is still presented as a delta on TLS. I've done some improvements. At least there have been several early implementations of this, one by us and one by Hannes. So we have some experience of what it's like to actually make DTLS and TLS work until we work together. That's probably easier in some stacks to others. NSS, the implementations are pretty unified, so it's actually pretty easy to get it right. Or to make it work at all, rather. Let me phrase that differently. We are taking the opportunity to improve some things that have made people sad historically at DTLS. I think there's some question of how much appetite there is for that, but I have some, especially now as TLS is winding to a close. Next slide. So the status of this is an individual draft by Hannes and myself and Nagendra. But I think let me put it this way. There are people who use GTLS. We want people to use TLS 1.3. We're going to have a GTLS 1.3. I haven't seen anybody else submit their own GTLS 1.3 draft. So I think it's pretty likely this is what we're adopting. Nobody's rejected that so far. So I'm going to proceed. I'm here to talk about the draft, and I'm going to proceed under the assumption that like this is the draft we're actually adopting. Feel free to submit your own draft if you hit on this.
So Martin Thompson, can we just actually get that question out of the way?
So there's a working group call for adoption that's currently out. It'll end on the 6th. I mean, it's procedure, right? So we just got to go through it. So whatever we decide here, we're going to stick in the thing, and then we can adopt it.
Fine.
I mean, I could, but I don't really. I mean, if somebody didn't submit another version of a draft that wants to compete, I think that's just another procedural thing.
I think it's great that we have the opportunity for people to object if they think that's necessary, and that's good information that no one is doing so.
Yeah.
Okay. Either way, I mean, if someone does a better job of this, then I can take more vacation. So that'd be interesting. Next slide. Right. So these issue numbers, the fact there's a gap here is because these are GitHub issue numbers, not because I can't count. I mean, also I can't count. But GTLS has this structure which we thought was pretty cute when we did it, which may not be as cute as you think. Where historically you used an implicit ACK. And so the way this worked is you had flight. Basically, client would send flight 1 of the protocol, and server would send flight 2. And the way the client would know that server got flight 1 was the server started sending it pieces of flight 2. As I put here, it's simple but also simple-minded. It's not quite as easy to implement as you would think, and it gives. I think limited would be the kind word feedback about congestion, by which I mean none. It handles single packet loss incredibly badly. So like if you have like a train of 5 packets and one of them gets lost, basically because you can't respond to anything in the other side until you've received everything, basically what happens is, like say the server sends you 5 packets and you don't get one of them, then the server has to retransmit everything. And so that's kind of grim. And we especially we started looking at like looking at various kinds, trying to implement it with things where you wanted to get congestion feedback as fast as possible. It's trying to be pretty gross. The other thing is it interacts bad. It already interacted badly. You never knew when like the last flight had been delivered, and so there's this goofy like 2MSL countdown timer, hold down timer in the in 1.2 in both the server and the client, but depending on whether you're resuming or not, for like the last person who sends the train has to like hold on to their train, and if they don't get the thing after a while, they have to retransmit. But then after 2MSL, you kind of conclude that maybe the thing must have been delivered and you give up, right? None of these things are great, and unfortunately, when you add NST, the situation gets even worse because because NST happens like at the end of the thing, and then key update's also bad. So we kind of concluded we should add some kind of explicit acknowledgement, which honestly, it's my fault we didn't do, and we should have done, back in 1.0. Next slide. So now the question becomes like, where should that explicit acknowledgement go? And there are two major options. One is to say, we'll retain the existing structure of implicit acknowledgements, except that every time you have like a dangling flight, then we'll add a dummy ACK at the end so that then it makes sense. And that's like what SIP does. So SIP has basically, this 3-legged thing with an ACK to tell you. So like, I've never felt that was like a great feature of SIP, to be honest. It's annoying logic, and it means that you have to now you're like, oh, well, sometimes to set the timer on this case, this case. So I think it'd be easier at this point, if we're going to bother with anything, to just say everything has to be explicitly acknowledged. People should feel free to argue at this anytime. And if we're going to do that, then we also probably make the acknowledgement substantially better than sort of like a trivial acknowledgement. So in particular, if we allow, so the easiest case to reason about is the server's first flight, which includes certificate, which is the one most likely to consume multiple packets. That if we have a SAC instead of an ACK, then you have a fighting chance at least of only doing one retransmit as opposed to a bunch. And you also might get some congestion feedback. My thinking was to do this, and the way you'd handle this would be that effectively in the easiest implementation, the servers you would basically just send the ACK as the beginning of your flight.
So Martin Thompson, would you do a quick style and acknowledge the records that were sent?
I'm getting there in a second.
Yeah.
Next slide. So, right. So the question then is, what's in the ACK? So one thing you could do is just be like exactly like. So by the way, the more rich, the more fancy the ACK gets, the more motivation there is for ACKing every flight, obviously. If you're just doing like I got the entire flight, then it's kind of like maybe the implicit ACK looks pretty good. So the simplest ACK that I think is worth doing at all is basically essentially just a list of, I got these messages, and these are handshake messages, not records. I'll get the records in a second. Your handshake messages and the time when you got them. This is like ripped off from the quick ACK. So as I say in this bullet point, this is a compromise between lots of data and convenient. It's very inconvenient for the sender to not know which handshake messages were received at all. But it's also, but on the other hand, it's also annoying if messages are split up between records, right? So the other thing we could do, by the way, is like, and I regret I didn't think of this earlier, is I should have done message fragment instead of message here. But the other thing we can do is we could also include the GTLS records which you received and the times they were received. There's no, I mean, this is not, I mean, so like, I think this is, we're in a good situation here in that like, when you look at the quick ACK, like that has to be sent constantly. And so reducing bandwidth of the quick ACK is actually pretty important, but this is sent about 5 times in the lifetime of a connection. And so like, I actually don't mind burning a fair amount of bandwidth to get a correct ACK. And I don't mind duplicating data, which is the second thing. So, while ordinarily you would never try to duplicate ACKs between like level A and level B, in this case it's not crazy to think you might do that. You know exactly what you send, and what that means is, and so I think what I wouldn't do is just say just the records, because then you have to maintain the record mapping. But I think saying also the records might be useful.
Yeah, you didn't mention it, but you're not sending the value of your clock. You're sending the value relative to when you received.
Well, you'll notice I just said timestamp.
Yeah.
I mean, we could do a number of things, right? So I guess so as I recall, what Quick does is it tells you it has a delay counter. So Quick has this very fancy thing. So again, this was intended to be a straw man. I wouldn't put this right in the draft. I guess the question I sort of have for people is, are people generally cool, like, number one, are people generally cool with the idea of having like ACKing every flight? Number two, people generally think that should be a relatively rich ACK. And 3, do people think we should try to like actually say something as much as possible about congestion feedback?
So yeah, I definitely think we shouldn't be acknowledging handshake messages because we tend to process the messages that we're ready for next.
Yes.
And so we may have, if there's a gap, we're going to be processing the things before the gap, but completely unaware of what's going on in the things after the gap, which means that someone's going to repair those things that appear after the gap as well as the things that were lost, which is bad.
Yeah.
Particularly when we talk about the encrypted handshake messages, which may not be decryptable at the point that you receive them.
Yeah.
So definitely follow the quick style. Include a list of the records that were actually received. We already do, like in Quick, we give them different numbers. We do need to record the epoch, unfortunately.
Yes.
Hannes, so in some of the mesh networks, 15.4 sort of thread-like mesh networks, but we ran into a few problems. One was the timer issue, which was for DTLS, for original specification, kept very short, specifically for the web users, for the RTC web users. So that's something we then later fixed, and that was fine. The other one was, as you said, was this issue of how many messages got acknowledged. So obviously you have to deal with a lot of packet loss there.
Right.
And specifically when we showed the stuff at conferences and these fairs, nothing worked anymore because the packets got dropped and you had to resubmit anything, and that made the situation worse. So I think it's definitely the right direction. Whether that specific approach is best, I don't know. Probably going along the sort of the quick route is something to entertain, and we will have to implement it and see whether it really works and try it in some of the heavier loaded networks, try it out in some mesh networks.
Yeah, I will be conscripting the person behind you relatively soon to help me design this.
I'm happy to assist you. The one thing I was going to note is you probably, my name is Ian Sweat from Google. You probably don't really need a timestamp unless you want like super accurate congestion feedback. So unless you have some compelling reason to add it that I'm not aware of, I would just ditch it.
I was just aping you.
Yeah, I mean, if you're running an entire connection for like 1 billion packets on GTLS, then maybe it's useful.
Okay.
So if it's a long-term connection, I don't understand.
Well, so my sense is then you have to have your own. Then you have to have your own congestion. I mean, really the motivation here is like, why are you waiting 3 round trips to get any kind of congestion feedback at all? It's not to like.
No, this is totally a good idea. I was just saying, like, you might be able to simplify.
Okay.
It. Let's talk offline because
Sounds good.
There were good reasons to use it.
Sounds good.
So Martin Thompson, just one other thing to throw in the pile. I want a new content type for this one, so we don't have to put it in the transcript.
Yes, good point. Yes, excellent point. Okay, great. So I will take the action of this thing here. I don't take this as like exactly the same. Okay. So Martin and I had this like little argument about which epoch. So I'm not hoping we're going to get to a resolution on this, but I just wanted to tell people about it. So because we have key changes during the handshake, the question then becomes which epoch should acts be encrypted under. So the easiest way to think about this is the server after the server sends his finished, right? The server is now sending with the application traffic keys, and so what is his responsibility? So when he sends the ACK of the client's finished, what should he send that in? And so Martin, I think, was like, I don't want to go backwards I always want to progress the key schedule forward. And I was like, things should be ACKed under the same epoch they were ACKed under. They're sent under. I'm not sure either of these is very compelling, to be honest.
Yeah, so Quick has an interesting position on this, which is, either one of them.
That might be okay too. That's actually, I mean, if you have a new content type, that's actually not crazy pants.
Adam Langley, Google. I would suggest neither of them. Does it need to be encrypted?
That's a good question.
Huh, interesting suggestion. DKG to the microphone.
While we're waiting for DKG and Ben Kadek, FX are cheap, right? Just give them their own.
That's a thought.
Yes, that's encrypted.
Adam Langley again. It would be nice in this case if epochs aren't cheap and that DTLS 1.3 only has 2 of them, right? No renegotiation.
Hey, we'll be there soon.
Okay.
So just want you to know, DKG, every time you say let's encrypt, I feel better.
Oh.
But
So
It's a new computer. It's very chatty. Apologize.
we have a whole bunch of potential, linkability concerns and traffic analysis concerns, and the more that we leave in the clear, the more we have to think about these things. So let's not do that. If both is fine, then we can just do both. I don't see this is not the protocol to cut security corners in, right? This is a protocol that's going to be widely used. So let's try to avoid those kinds of concerns.
Adam Langley, I think that's a decent argument. I suspect we don't lose anything because I think if you just look at one side transmitting packets, you get to see all the information you would see otherwise because this information feeds straight back into publicly observable retransmissions. But let's not worry is a decent argument.
The other one here is that the way to implement this and the way a lot of stacks implement this is they install a set of keys that they use for encrypting every single record they send, and having different keys for these things is awkward.
Well, how you get bypass encryption to kind of pain too, yeah.
Yeah, I mean, we can sort of create these exceptions for things, but at the moment, the easiest thing to do is to simply shove it into the record
So
processing.
what I would suggest actually is why don't we actually try to do an implementation that has ACK of everything, and then we'll have a better idea of how painful this is.
Yeah. The other thing to note is that we don't have any way to composite 2 different records of different content types if we start talking about the next things.
You can't use them in the same datagram though.
You can show them in the same datagram, but
That's actually
that's what's possible right now. But
the GTLS, no, it's true in the next one too.
Okay.
The GTLS strategy is always to shove things in the same datagram.
Right.
Because you want to remove the length is your point. You want to use the UDP length as
I'm thinking about removing the length. I'm
Yeah.
thinking way ahead. Sorry.
Okay, sorry. Okay.
So to be continued.
Yeah, clearly I was a bit confused. Right. So, right. So, again, this is probably not trying to get resolution, but I just want to get people a sense of it. You know, we have this key update thing, and in TLS, it relies intensively on the reliability of the message stream, because you say, you know, I'm updating, and that has two effects. One is it says the next message I send will be in the new key, and the second is it says you ought to update. Or you actually, it says maybe you ought to update, maybe you don't. Now that we have this flag, right? The flag actually makes the problem somewhat worse. So it's clearly the case that you need epochs to solve this problem, because the key update can get lost, and so the key update is like half pointless. It doesn't serve the point of telling you you're in the new epoch. The current draft basically just sort of kept it all together, and basically when you see someone send a new epoch, it forces you into a posture where you have to send the new epoch, and it addresses the concerns that people had about sort of unbounded epoch flap by saying basically you can only do one key update, essentially one update at a time, until the other side also updates. So so you get lockstep updates like the original design we had. Of course, the annoying part of that, and the reason we didn't do that in TLS, was that it means that if one side is transmitting much more aggressively than the other, they're basically forcing the other side to constantly key change, which may or may not be annoying. So I've been trying to think about whether I like another design better. The other sort of obvious design is to continue to use key update and use that to tell the other side about whether they should be to split out the idea. So right now the key update two things. It says I'm changing keys, and either you should or you shouldn't change keys. And so the way you deal with this would basically, you'd say you send a key update and you flip the epoch, and you use an act to keep the update reliable. And when the other side receives the key change, he doesn't do anything until he receives the key update. And when he sees the key update, then he knows if you wanted him to flip or not. So that's another way to handle it. That'd be a little more like the current TLS structure, and might be a good idea, might be a bad idea. I'm sort of on the fence about all this stuff. But again, this is sort of like, if people have thoughts, I'd love to hear them, but I think we're not close to designing this yet. So,
having implemented one, I have a.
Of course you do. I guess one way to think about this presentation discussion is an opportunity to have a first impression of what these things are, so you can think about them. And if anybody wants to volunteer to actually address one of these problems and take it on and tell me what I should do, or we should do, that'd be fantastic as well. Okay, next slide. Right, so this packet header is pretty large, and yeah. It was a different time. It was a different time back then. Okay. So anyway, it'd be nice to make it a little smaller. Also, it would give us room for connection ID, which I hear certain people want. I mean, the sequence number is like reasonable. The sequence number is not crazy. I mean, you did want a sequence number, and all these things were like. I will tell you that like having to have like half the sequence number in the packet and part of it not in the packet actually is incredibly irritating. So there was some reason for that. The epoch I think was always too large. I think somehow we thought we might actually renegotiate 257 times. So I don't think that's going to happen. So we have to make that smaller. So again, I'll just float Martin Thompson's proposal, which is not the only proposal for how to shrink this. Next slide. So Martin, I thought I put a line break in there. Anyway, I'm worried we don't have the new slides, because I'm sure I put a line break in there. Well, we'll see what happens in a minute. So basically Martin proposed, so one problem we have is we do use some of these values for demux, so we have to pin down some of these values. The Martin suggestion was to have a relatively short sequence number, and then basically have the rest of it be implicit with a counter and a 2-bit epoch value. It's possible, by the way, so the reason you need a 2-bit epoch value is that during the handshake, there's some conditions where you might have three kinds of keys outstanding, or yeah. And so the other way you might imagine handling this is we've been talking about in Quick having a long header, short header kind of form, where there's basically a short header which you use for basically everything, but a long header used for the handshake. And so the long header, of course, gives you plenty of room to do everything you want to do, and then you don't need to be really aggressive at bit fiddling.
Yeah. So to that point, we already have that because the client hello has to use the
Yes.
old record format.
Yeah.
And so does the server hello.
Yeah.
So
But those are unencrypted, but yes.
sure, but those are
Yeah.
the long form.
Yeah, true enough. So I don't know. We spent. I think again, this is actually an invitation for some enterprising individuals to sit down and do what John and Martin did about designing a brand new like long header, short header flip or some other thing.
Adam Langley, Google. It does suggest that, if you have some WebRTC session and you unplug the network cable and the sender goes through 2048 packets, now you're desynced and you're doomed.
Yeah, that's sort of the gross part, right? Okay, next slide.
Just before we jump on, like the quick folks, like how bad is desync with short sequence numbers, and how short are the quick sequence numbers?
And this is like one.
Okay, so just to repeat for the microphone, Ian Sweat said 2 bytes seems fine.
All right. Next slide.
This is only 1.5. So
Can you scroll forward a little bit? 2 more slides. I want to see if my. Yeah. Next slide. Okay, I did make it. Good. Okay. Go back. Next. Okay. Yes. Good. So these are Hannes' slides. I'll try to present them in German. Right. So this is the same issue we had that we have in Quick, basically, and it was discussed yesterday in TSV area, which is that NAT bindings for UDP are tend to be incredibly short. And so you can find yourself in a position where your device goes quiescent for a little while, either because it's not sending or because it goes to sleep. And then you suddenly want to send packets, but your NAT binding has gone away and the server can't remember who you are. And there's a bunch of other cases that people are bent about like inability to distinguish connections from the same 5 tuple. And so the solution is of course obvious, which is you shove some identifier in the record layer header that says like here's a connection I am. Unfortunately, back when we used to do this, it was also a different time, and we didn't have like DKG to keep us honest, and so suddenly people are more worried about the privacy implications of this. Next slide. Yeah, that was a shout out, man. It wasn't a criticism. Next slide. Right. So I guess the first question is like, when do you start shoving this in? Which is a distinct question from linkability issues. I think obviously the client hello can't have it anywhere but in some extension. And also client, if you think about how we thought about this in Quick, you really want the server to dictate it on the client anyway. So it's actually not. So actually, you probably don't want it to be in the client hello, other than I would accept it. So the 2 choices effectively are like everything from the client hello on, or basically once you start going into application mode. My instinct is if you're going to bother to do this at all, like it should be everything from the client hello on. But we can figure that out. That's more a sort of tactical issue. There's also a question of whether you should always use it or you should negotiate it. I think that when we talked about this in Quick, people work with that packet size bloat, so there's like an urge if you don't think you need it to negotiate it. So I think probably we should negotiate it. It's not a pretty difficult thing how to negotiate it. The difficult problem is that congratulations, you've just created like this great linkage identifier, and as long as you never change your IP address, like who cares? Because like that's a fine linkage identifier anyway. But if you're doing anything mobile and you're changing your IP address, suddenly you have like a linkage problem. So this first option, of course, is just like have a linkage identifier and suck it up. And then we've talked a bunch about various mechanisms for doing this. They don't have linkage identifiers, and I'm going to briefly talk about those in the next slide. Mostly is an intuition pump for you. I think they are just on the bare edge of acceptable, to be frank. We're going to also have the same conversation in Quick, so I sort of want to start introducing the ideas. Finally, once you have these, you need to find some way to demux the packets on the way in the door, because conventionally, the way you build your stack is you bind things to host port quartet. And so it's just worth noting as an implementer, you either have to have your stack be smart about this, or you need some sort of pre-filter that basically knows how to do the demux. That's my impression. Typically, people do it with a pre-filter. My understanding. Okay, next slide. So 2 designs I'm aware of are this thing that's called hash chains, and which is also going to be done with encryption, and type of buckets. So I guess one thing I want to mention is that the design everybody usually comes up with initially doesn't work, and that is to give the client some key that the client then uses to encipher, basically encipher a counter, right? And that doesn't work. And the reason it doesn't work is that that you need to, in order to decrypt those things, you need to know the key, and that means every client has to have the same key, which means that all I have to do is connect to the client, and all I have to do is connect to the client and get to the server, right, and get the key, and then I can link everybody, right? So you can use that strategy, but it doesn't. But the implementation is going to be very different. So the two strategies that basically work are: you give the client some secret, and the client uses the secret to generate a chain of values. But every client has his own secret, and then the server has to basically, based on the packet number, induce what the next the packet number or the imputed packet number, deduce what the next thing it might expect to receive from the client is, and then like basically go through either a table or look them all up and figure out what the next one is, and that's how it knows. And this is the first idea that people kind of this kind of works, but it has extremely unpleasant performance properties. In particular, that it means that basically an attacker can force you to do an enormous amount of computation or create an enormous amount of storage that basically is linear to the number of clients you have, because basically what it does is just send you a random value that doesn't correspond to any next thing. And now you've got to either do, depending, and you can pre-compute, so you can have like a big table, but you got to either have either an enormous table or you got to do a lot of computations. That sucks. I guess I should also mention you can do some public key cryptography, but I don't think anybody thinks we're going to do like an elliptic curve Diffie-Hellman on every single packet. So that's not on the table. This is why public key cryptography was like invented, right? As I say, this is on the barrage acceptability. The other thing that's on the barrage acceptability is what DKG and I invented the other day, which we've been calling like token buckets. Next slide. So the idea here is that the server mints a pile of tokens and gives them to the client, and the tokens can all be encrypted with the same key because the server never gives it out. And then when the token comes back, the server decrypts the token and he knows which client it came from. This is actually probably how you build the connection editor anyway, even if you didn't want a lot of them. And the only new idea here is you send back a lot of them, and the client uses like a different one for each packet if it possibly can, and then the server has to replenish this client stock with acknowledgements or somehow in band. Obviously, the annoying thing about this is it consumes like a lot of bandwidth. It consumes bandwidth in two ways. First of all, it means that the connection ID has to be a certain minimum size because it needs to be big enough that you can store effectively a counter and the user and the connection, the real connection identifier inside, because you need everyone to be different. And the second is, of course, has to fit conveniently in a cipher block, and so that kind of shoves you into specific structures. And of course, you have to send it twice, so it's twice as big, effectively. But this is the best I got. I'd love to have something better because I think this is just barely acceptable.
Christian Rittemer. I'd like to throw in another requirement. It's something that we are starting to work on as part of the privacy analysis in general. It's very hard to look at privacy at just one layer. I mean, I'll give you a typical example. Suppose that you're in your browser and you say remove a history. That's really nice, but if you have kept, say, the same IPv6 address underneath, the next thing you do is that you load a web page, you go through an advertisement auction, and your new address, your old address is there, and everything is relinked.
Yep.
And so the more you think about it, the more you believe that you need some kind of a privacy event that go through the whole system and triggers something like, by the way, it would be nice if you change your identifiers now.
Right.
Okay. And so, like, if you do this kind of remove the browser history, you'll have events that do things like, maybe you should change your MAC address, maybe you should change your IP address, maybe you should change this, you should send that. At that point, you should be able to flip the identifiers that you are using as connection ID or whatever to make sure that you don't have the old ones.
Yeah. So thanks for pointing that out. You reminded me I skipped a step, which is that I think there are two modes one can imagine being in. One is the mode you're talking about, where you think you have a concrete knowledge. The concern we've had, and it may be a wrong concern, is you may get unintended unintended transition events that you don't know about and that you're trying to defend against those. But yes, if you...
And from a privacy point of view, I am not too concerned that you'll not randomly lose the port, so you use another port and it be linked.
Right.
Yeah, because it's kind of unavoidable anyhow, because you'll be linked by other things.
Right.
But the organized event, we have to be very careful that we do it right.
Yeah. So I think that's actually something that this handles relatively well in terms of you just skip the replenishment step, right? You just say, here are 5. And then when you
Yeah, I like that design because it fits well with precisely the explicit event, like do something now.
Yeah. Sure, Langley.
I've broken my own idea while standing here, so I'm going to sit down.
Okay, good. Too bad. I wish you had a good one.
Eric Nygren, the token buckets also have the nice property from being both stateless, but they also have the nice property of working well with load balancers, because it means that you can statelessly steer stuff to the right place.
Yeah.
One thing though that might be worth thinking about there is whether or not, if you had the token sizes be variable length, then for some cases, like the IoT cases, it may be that you don't necessarily need the full encrypted tokens, and the server could just keep track of the table of all the ones that's given out.
I think they definitely should be variable length.
Hi, Rich
And didn't unbroke his thing.
channeling for Scott Flory. He's gonna have to post this to this list.
He's also in the queue here, so we have the technology to put him up.
Oh, cool.
Oh,
Great.
bring it on.
All right.
Yes, can you hear me? Okay. Right. I had a random idea. Instead of the server giving to the client n tokens, it picks a random value. It sends that value to the client. It also encrypts it with its own public static key. And then when the client wants to encrypt the message or use a token, it picks a value I. It hashes that with the value R that it received to actually generate the key, and then and to the server it sends the encrypted value, a version of R and I. That allows the server to actually recover the key that was actually used, and it also you don't have to pass every single token every single time. It reduces the amount of tokens the server has to give the client, because it only has to give it 1, and it doesn't increase the client's token that much. Comments, or should I put that on the mailing list?
Mailing list, I had trouble following it at least.
Okay.
Adam Langley, Google. I also wanted to suggest a stupid idea, which is at least equally stupid. We can, like the client could public key encrypt its identifier, and then the question is, can the client quickly come up with enough public keys, which I think it can, and the server only needs to do the decryption if it doesn't recognize the source tuple. And then, if some clients floods it with random source addresses, well, the server has to rate limit how many decryptions it does so it doesn't get flooded out.
That's an interesting suggestion. It's expensive for the client, right?
I'm sorry?
It's expensive for the client, right?
I think that was why I sat down, but I think I have some crazy idea that may work that makes it not expensive for the client.
Okay.
Okay, we're going to clip the line on this issue after Phil.
We just need Dan Benet here, I think, is maybe the real answer.
This is DKG. I just wanted to, as folks are thinking about this, I wanted to just clarify that the idea that you're behind a NAT and then the NAT just transparently accidentally rebinds you to some external tuple, that case might be more common than you think. So think about the tethering case where you've got your mobile phone is providing access to your laptop. Your laptop isn't going to actually see the network transition events, even though you may actually roam onto entirely different networks. Right, because your laptop is just going to continue to get the same DHCP responses from your phone as the DHCP server. So that case of the client not being aware of the transition, it would be nice to not accidentally leak this stuff, even if there are other forms of linkage that could happen.
To add to your comment, where we initially noticed this is obviously not in a mobile phone case, because those are sort of devices that are very well capable of doing all sorts of things. And also not in the mobility cases, because there are fewer IoT mobility cases despite all the vehicle talk and so on. But for example, We had sensors in concrete, battery powered. Obviously, they are not moving, or at least hopefully they are not moving. And they need to run on an extended period of time, because if the battery runs out, like literally the story is over. And so you want to have a solution that doesn't require a lot of computational effort, because otherwise you could as well restart the whole DLS exchange and get some new identifiers, or you can, or you just keep the connection open and you don't sleep all that often as a device, because that's when the NAT binding expire. But having something that is at least a one variant that is not too heavy for those cases that are really about static devices, which is a common case, talking to some cloud infrastructure where there's unfortunately a NAT in between, which still happens far too often. And having that, and having some of the more sophisticated cases where you potentially have the situation that you mentioned, or mobile devices which are more powerful, maybe have no energy problem, or are not running battery powered in a classical sense. I think that would be useful for us.
Ian Sweat. So I think it'd be great to get a little bit of better characterization of like how often we think this is going to happen and under what circumstances. Because right now, I don't think anyone has actually tried to like tether and like migrate networks and see what happens. It's very possible the whole thing just fails because like some terrible thing that we're unaware of happens. So I think it'd be kind of nice to get some actual like understanding of what the real world like incidence of this is. But I think after looking at this again, I think this is sufficiently complex and sufficiently costly that it would be easier to just not send the connection ID on like in the quick case, all the short header packets than it would be to do this.
Okay.
So which is a deployable but like ugly as ever-loving God solution. But so I think we have to have the bar be whatever we come up with. So maybe Adam's thing is going to be super clever and that'll solve all our problems.
So what is complex and costly about this? The encryption or the replenishing?
I mean, it's a fairly complex extra mechanism. I guess I was thinking about the token bucket.
Yeah. Right.
So I think it's just a moderately complex.
But I guess sure. I guess the design that we had in our heads when DigiGen discussed this was that this has a degenerate case where the server just sends you one token and you have to read it all the time, which is effectively the situation we have now, right?
I should have added that I actually support like us adding this to the transport, and I think it's a cool feature. But I think using it in this way, where like you try to get it like a new one for every single packet, is sufficiently costly that it's like basically burdensome enough you'd be better off not sending a connection ID.
That may well be the case. Yeah. Bear in mind, we're trying to solve a problem which may not be a real problem, but it's very interesting problem. Yeah, blah. It's an interesting problem to try to solve though, so hence we're spending time on it.
Wilhelm Baker, I'm just going to say that I think that it's an interesting problem, but not the sort of problem that I care to try and solve with 200 of my best friends in the room. I think that this is something that would be better done in a side meeting.
That's why I clipped the line. We get to the point where we're designing. So,
is there a plan to have a side meeting? And
so we've already had sort of what I've been calling a connection ID task force, trying to kind of meet and brainstorm about this. We've made some progress, I think, but not as much as I was hoping. I think we've got a pretty good job fleshing. Martin and Hannes in particular done a pretty good job of fleshing out like the issues. And we've done a less good job of actually solving the problem, but I think that it's already been valuable. But I think it's already been very valuable. In particular, this point Ian is raising, I think, is critical, which is to say, like, we need to figure out, like if we hypothetically could solve the problem and have a new token for every packet, would that in fact do anything? And if the answer is no, then it's a much easier problem. We don't have to solve it. So I think that it might be worthwhile trying to proceed along two axes. And I think this also is a cooperative thing between us and Quick, at least, is that proceed along two axes. One, attempt to evaluate the problem case and figure out whether this actually is a problem. And the second is try to solve the problem, assuming it is a problem.
We're running out of time, so that's also why I'm doing it. So next. Okay. So I mean, I think the plan is to continue to do your get together and figure it out. We can take it to the list.
No, and if people want to be involved in that, they should contact me or Thompson or Hannes. Next slide. Right. Okay, this is actually an idea someone raised to me, but I think is now maybe disclaimed. It's annoying. I may have also misunderstood it. So that in both TLS and DTLS, you digest the entire handshake message transcript into the keys and the finished and stuff like that. And in both cases, you include the message header. But in DTLS, you have to make this synthetic message header, which is like the idealized platonic message header that would have happened if things had not been fragmented. And so sometimes that actually represents the actual messages if they're small enough, and sometimes it represents basically like I took them together and I like just made some fake values. But the way you do it actually is at least in my stack, is you like assemble the handshake messages to one block, and then you make this fake message header, which would have been the message header had it all been, no matter how it would have appeared. And so it's annoying, and it's got like these bogus values which have to be hashed, which doesn't really cost you anything. But it also means the TLS and DTLS transcripts are different even for the same handshake, which is somewhat annoying. So someone who I won't out, but they can out themselves if they want, suggested to me maybe we should just stop doing this and just hash in the TLS message header, the part that is common, which is the TLS message header. I don't think this is a big deal. This is another one of these cases of like two consistencies fighting each other, namely the consistency of having DTLS 1.3 and 1.2 being the same versus the consistency of having TLS 1.3 and DTLS 1.3 being the same. I don't have a strong feeling about this. I am raising it merely in case someone has a strong feeling.
David Benjamin, I'm not sure if you took my mentioning this nuisance as a suggestion to change it, or if you were referring to someone else. I would actually rather we not change it,
okay,
because we don't have a time machine, and since we still have to support DTLS 1.2, that means the client hello, which gets put in, gets put into the transcript before the client knows the final protocol, like needs to switch the header partway through, and that
right. So that was what I was trying to say when I was saying that you may have disclaimed this. So I guess maybe I should preface my remarks with, I know that there are things, this is like our main, like in TLS 1.3, we use an opportunity to clean up a lot of the things that we're sad about it in TLS. And while DTLS 1.3 is obviously simpler because it is more like it's like a delta on TLS, there are still things that people are sad about in DTLS. And so it'd be great if people who have things they're sad about in DTLS would surface those as soon as possible so we can see if we can resolve them. And in some cases, it may be the case that it's not worth doing because we're just already baked in our code. And in some cases, they are worth doing. But I'd rather have that list now so you can make that evaluation. So please consider this people who are sad about pieces of DTLS as a call for you to tell me about them. And at least we can discuss them and then we can decide not to do them or do them as we please. And don't necessarily take me putting this up on the list as, up on the slide is saying I think we should change it, or I think you thought we should change it, but merely that I thought we should discuss it. But I thought it was worthy of discussion. With that, I think I'm done unless other people have other things about this draft they're sad about that they want to talk about now. Okay.
Cool. All right, so we're a little behind, and basically that means we're going to sacrifice the final presentation of trying to figure out what to do with the drafts. So, Melinda, you're up next. We'll see how this goes. Thank you, Ecker.
I actually may not need the entire 15 minutes. We may be able to recover some of this. Yeah, so this is an update on the draft on conveying the entire DNSSEC validation chain in a TLS extension. We think we're pretty close to done with respect to the TLS piece of it. The things that we need to do before going to working group last call are to add pseudocode and test vectors to the draft. We need to add edits based on Victor's most recent comments. We know that there are going to be additional DNS related issues that come up. So we've talked a little bit about sending a request for comments to the DANE, DNS ops, and deprived mailing list prior to during working group last call, but I think we actually need to do that before.
I think what we can do is you get the draft done if you do the edits. When we do the working group last call, I can just CC all those other working groups, and then we can add them in the 2-line, and essentially they become, it's like a pre-IETF last call essentially.
Okay.
So,
yeah,
work.
Either then or before then. I'm a little bit concerned about the comments from DNS land, although the comments we got from Victor last week were terrific, very helpful. Okay, so that's basically what we need to get done. What's the next slide, please? Okay, so next slide.
So it's this one.
Yeah, sorry. Okay, so we're currently at the 03 revision. Updates and so include adding TLS 1.3 support, added a section on raw public keys, softened the language on record order, updated the discussion of the unknown key share attack. This was based on feedback from Martin and from Victor. We've added some edits for language and consistency. We think we're in good shape with respect to the TLS piece. And that's kind of it. There were some recent discussions on the mailing list that came up about certificate compression and so on. I think it's really important to keep in mind that what we're trying to do here is minimize latency related to DNSSEC and gain validation in the browser. So, for that reason, we're trying to minimize complexity and minimize processing overhead. So, questions?
So sorry, I have comments on this that I'm DKG. I have comments on this that I should have already sent to the list that I haven't. It turns out with the way that we specified the DNS over TLS that we want to use, in some cases, SRV records, which means that when you're connecting, just the name that you're connecting to in the SNI alone may not be sufficient for the server to figure out what chain to craft, because they may need to actually do the SRV delegation.
Mm-hmm.
So we may need to actually add some content to the client extension instead of having it be empty, so that the client can specify what they were looking for.
Okay, yeah.
So I'll post that to the list.
Yeah, definitely. We've been trying to minimize that, but we know that, the amount of stuff that the client sends up, but that's sort of an information piece rather than a negotiation piece per se. So, yeah.
Yeah, so anyway, just to, right, if the client is looking something up via SRV, then you want to follow the full chain, you need to follow the chain to the through the SRV record. Instead of if the client's looking something up by name, then you just have the chain to the name, which doesn't give you the full secure delegation.
Right, and so your point is that ultimately the name is still the same, that the string the client put in originally is still the same name that you're seeking. It's just that the server doesn't know necessarily that you walked via SRV records to get to that name as opposed to just following A's and C names and whatnot.
Right, the other potential situation is that the client followed an MX record, which is SRV, morally equivalent to an SRV, right? So the server, when it's calculating the chain it needs to send, needs to know what validation path it needs to follow.
This is actually a general problem with DNS in that sometimes you're using DNS names to describe services, and sometimes you're using them to describe hosts, and the DNS architecture doesn't differentiate between them, but we are in working groups that are building on it, and we're differentiating between them differently in different places. So this is something that maybe we could get the IAB to actually look at and tell us when to do which. Because it doesn't matter a whole lot, but it does matter that we do it the same in every place. Because if we don't, then somebody else is going to be coming up and saying, well, that is incompatible with this.
Mm-hmm. Yeah, that's a good point.
Adam Langley, Google. It's been a very long time since I wrote this draft, so things may have changed. But it used to be that the verifier was required to check that the records being presented always moved you towards the expected destination. And now if there's SRV records, like that has to change as well, because you might be, the server might be saying, well, we're actually, your path is going off over here and you'll end up in the right place honest, but you won't always be monotonically moving towards where you expected.
Another place, I think as I mentioned, we've sort of relaxed some of the language on record ordering because of the way that records are returned from DNS servers and the capabilities currently in common DNS libraries.
Yeah, so I guess I feel like I'm not comfortable enough with DNSSEC yet to evaluate like whether this is implementable so when I read through the section on ordering, right, it seemed like you had some ordering rules, but then I look at the section where it talks about CNAME and DNAME records may involve multiple branches. And so I guess my question is merely, does that create an unambiguous list that I can parse correctly like people feel like that's the case because I believe someone tells me that I'll believe them, but I'm unable to evaluate them myself, right?
You want to evaluate it yourself?
I'm unable to evaluate it myself, so I want to make sure that's being considered. Like, so that whatever bucket of things you give me, like either I don't need to know where the breaks are, or the breaks are straightforward. Is always the question I'm asking, I guess.
Yeah, we can add some language to clarify that. We're assuming that you're using a library that doesn't require strict ordering.
Right. So I mean, is in fact the case that really the only important thing is that the terminal, the first thing that appears represents the entity, and everything else is just a bucket?
Yeah, basically.
Okay. I mean, so I thought I did catch some text. Maybe I missed it, but I thought I did remembering wrong. But I thought there was some text about how things were supposed to be ordered. And I wonder if maybe we should simply relax that text entirely. I'm not sure that text has been that useful in TLS.
So yeah, as I said, the original design, which may be too limited for the real world, was that every step moved monotonically towards the destination. But now, if it's just like TLS certificates, where the leaf is what you want and everything else is a bag of stuff, yeah, that's a different world, and maybe that's necessary. In which case, all the ordering stuff should be removed.
Okay, cool. All right, cool. Like I said, you spin a version. The reason why I want to do this is because if you work in group last call with the other groups, they'll actually read it for real. So if they come back and say, oh, it's all horrible, we can just come back and fix it here and then do another working group last call. So
Yeah, that's fair enough. And also Paul has promised to review soon. So
Is Kathleen here? Oh, I see Kathleen over there. She can weigh in, but I wonder if we should simply actually get a formal review from someone in the DNSSEC community, so we have like something written down they send us, and maybe that ends up being Victor, in which case mission accomplished. But I think that's something worthwhile soliciting. I don't know.
yeah, I'd be more comfortable with more review, frankly. So.
Okay. All right, cool. Thanks. Now we're going to talk about certificate compression.
Hi, my name is Victor. I work for Google, and this is the draft on certificate compression, which is a joint work with Alessandro Ghedini from Cloudflare. Next slide. So first, the idea of certificate compression is we want to compress certificate, and before we discuss how we do it, I need to discuss why we are concerned about. And before we discuss about how we compress certificate, I want to talk about why we want. First, certificates are the largest part of Handshake. Typically, Handshake has like 400 to 500 bytes, which are non-certificate, and then certificate chain can be 3 to 4K. And we want it to be smaller because the TLS handshake is a critical part of the connection, which means nothing happens before the handshake finished. And so if you lose packets, the longer your handshake, the more probability that you lose packets and will have to retransmit. The second reason, more interesting reason, has to do with how we intend to optimize TLS handshake in Quick. And in order to do that optimization, we have to limit amplification factor, which means making our server hello smaller. Next slide. So in TLS 1.3, whenever you first connect the server, you do what we call a 1 RTT handshake. In reality, it's a 2 RTT handshake because it's done over TCP. So the way this works is you first do the TCP three-way handshake, you send SYN, SYN-ACK, ACK, and after you do that handshake, essentially what you get is the client proves to server that it owns the IP, and it is consenting to server sending it information, which is crucial, because otherwise what you can do is you spoof the client, you send the fake client hello to a server, but you spoof the IP address, and that way you launch an amplification attack on that target IP. And this does not work with TLS over TCP because you first do the three-way handshake, and then you send server hello. So next slide. In quick, we just send server hello. And we get, and we effectively cut one round trip, but what this means is that whenever we have to be concerned about amplification factors, and we cannot make a perfect amplification bound, but one thing we do is we mandate client hello to be padded to some size, and we reject client hellos of certain size. That's one way we bound amplification, which means you have to. And the second way, we limit the number of packets we send in response to client hello, and we want to make this bound lower, which effectively means the server hello has to be small. This is why we want to compress, because if we don't compress the amplification bounds we get, we have to effectively allow 5x simplification, which is not the end of the world. It's not as bad as NTP, where the amplification factors go up 80x and higher, but it's still something we can improve. And with compression, we can achieve bounds of 3x, 4x. So next slide. So how we intend to reduce the size of certificates, we are just going to compress them with regular general purpose compression. And I took a sample of certificates, the entire certificate chains from a sample of popular websites, and I applied Berkeley, which is an algorithm which currently used for web fonts and content encoding in web, so it's already widely spread and widely adopted. So, and I found that at median we achieve 30% size reduction, at 95th percentile we achieve 50% size reduction with Berkeley at highest compression settings. And this effectively allows us to fit approximately half of certificate chains I looked now fit into 2 packets, which allows for 2x amplification factor, and vast majority of them now fit into just 3 packets. So now the question is, so why does general purpose compression work? Since, as we all know, certificates are mostly cryptographic material, so there should not be nothing to compress. And the answer is 30% of certificates is cryptographic. Next slide. 30% of certificates is actually cryptographic material. 14% are subject alt names. That is the list of host names for which certificates authorized. And this is by now all the very basic information you need in a certificate. And the rest of it is just identifiers. 20% is just ASN1 overhead. And a lot of it are just some various strings, which turns out are compressible. And another reason why chains compress well is that leaf certificate specifies which certificate signs it, and those are byte for byte typically byte for byte identical both in leaf and in parent. So this works out fairly well. And the idea is that we just take the certificate message and we compress it. And that's pretty much it. The proposal is very simple. Yeah. Next slide.
Well, before you go, Rich Saul's clarifying point. That's a brilliant slide. Just astounding.
So I have several questions about this. Maybe you can answer, maybe you can't. Oh, Eric Rescorla, this is nice. Are these certificates principally RSA or are they principally ECDSA?
Most of them are RSA. I think the average key size is like 2038 bytes.
Nice.
Which means most of them are 2048 bit RSA, right. But some of them are ECDSA. So
right. So the second thing I was going to say is I have an opportunity for you to shave off 32 octets off the keys if they're ECDSA, which is by implementing point compression.
Could you repeat the question?
Sure. So no, well, that'd be fine too. But so hello, Ryan. So ECDSA keys, right? You said a point, right? And but half of those, but the Y at that point is redundant. And so if you implement point compression, then you only need to send the X coordinate and the 1 bit for the Y, and that lets you shave off another 32 octets off every ECDSA key. Now it's a hack.
If you'd like to do that, the CODA working group is doing ED25519 sys.
Right. Well, that's of course another alternative, right? That actually removes the problem entirely. But I'm assuming there's a lot of ECDSA certificates out there. Fair enough.
Yeah, I think at this point, like we're just like moving to 25519 because if we start doing that now, the timeline will be the same. And like in general, compressing, just using ECDSA makes such a dramatic change.
Yeah, and those law, right?
But then we're only affecting 30% of this.
Right. And so the second question is, do you have a sense of, so you're suggesting encrypting the entire certificate message, right? So do you have a sense of what happens when you add SCTs and OCSP responses?
SCTs I have sense of because they're already like embedded in those certificates. So, I mean, I'm not sure how well those compress, but if they don't compress, nothing happens with them.
Okay, but there may also be SCTs in the TLS extensions as well, right?
I assume those are similar structures. So
I think so too.
It would not be that different.
Yeah, it's Ryan Sleevey. Yeah, and what Edgar was touching on with OCSP, you know, from at least from the browser side doing the OCSP analysis, many CAs are putting, you know, additional certificates within the OCSP response, and I'm wanting to make sure that, you know, if the goal is the amplification attack, that the OCSP responses are also going to be appropriately covered, you know, as part of the certificate message and as part of the compression scheme, because you're going to find a lot more redundancy. I can think of several CAs who put their entire certificate chain in their OCSP response, and, you know, you get this nice, lovely 9K OCSP response for a 1K certificate.
The answer here is that fortunately OCSP is now part of certificate message, so they're all compressed.
Right.
So this actually works better with 1.3 than it did with 1.2.
Yes, and from practical standpoint, I don't think we actually are going to deploy it in 1.2 because 1.2 has the middle box problem and 1.3 encrypts certificate message, so we don't have the middle box problem.
Right, so you have more freedom what to do. Thank you.
Discussion. Any other questions? Any idea on how many people think this is a good idea?
Yeah, so, I mean, who read the draft? Please raise your hand. That's not bad. It's like 10 or 15 people. Yeah, all right, cool. Martin, before I go on.
Yeah. So Martin Thompson, as commented on the list, I would like to know just how often this is useful when we have cached info. And that's an analysis that would be interesting to see. And the other thing was preceding the dictionary with all the OIDs would be kind of handy. We'd have to do that in a sort of non-biased fashion, but we could potentially do that.
So with regard to number one, so you don't actually get amplification concern most of the time when you do resumption. You talk to server, because you have resumption, and then you have the source address token.
Right.
So you already can prove your source address.
Most of the time.
And with regarding to number two, pre-made dictionary is definitely something we considered and something that I will attempt to make, but I had multiple discussion, and basically we would have to hand assemble it. It's like original intention was to assemble it based on corpus, but it's bad idea because corpus might be biased towards certain practices which are practiced by. And so at some point, if we compile a dictionary which is good, we will we will definitely put it in this draft.
Philhan Baker, Komodo. The Mikali revocation patent expired last year, and that potentially allows you to compress the OCSP token to a single hash value. So now the thing that I've got to work out is, so we're actually building infrastructure now to see whether we could use that as an alternative to OCSP. Now, one of the things that might come into play, though, is I don't know whether that would actually be a saving overall, given that you're compressing other things, because it might well be that the serial number and the data in the OCSP message compress better. But it's something that probably you should be taking a look at.
Thank you. I'll definitely look into that.
This is DKG. Great work. I think this is a good thing to have going forward. I just wanted to point out in regards to cached info that the goal of this is to prevent amplification attacks, and the amplification attack header isn't going to send the cached info. Okay.
Well, so the amplification attack is, I will specifically mention, we have a fallback. That is, if you do not implement compression and we have to send you 5, we will essentially fall back to 2 RTT handshake. So this is to combine both amplification safety and 1 RTT handshake.
So then same point, like clients won't advertise cached info if they want to actually do an amplification attack. But I really like this work. Some of the comments that we got about cached info is that browsers need stateful storage for cached info to really work. Persistent stateful storage to make it effective. This makes it just that it's nice that it doesn't need any stateful mechanisms for compression. zlib, I really like this. Thanks.
I will just mention that one of the reasons cached info is not a full answer to the problem is that I'm primarily concerned to the cases where we've never talked to server before. And this is an important case to optimize. Because most of the time you've talked to server before, you actually can just do resumption. And in TLS 1.3, we're making much long-lived session tickets. So that works much better than in 1.2. Okay.
Kyle Neckrits, kind of on the same thing of just the client's not sending the cached info. If clients do not support this certificate compression, do you plan to just factor that into an increased probability of requiring a source address token?
Well, if clients do not support this and our certificate chain is too long, we will just say hello retry request with cookie.
So this is a way for clients to avoid that.
Yeah, it's a way for clients to avoid this penalty.
Adam Langley, Google. I just wanted to mention the amplification factors are what Victor worries about because he's worried about Quick, which is great because I want him to do that work hopefully this year. But it's also attractive even without Quick in TLS because websites these days are exceedingly complicated. They're going to many dozens of other hosts for sub-resources. And if you're hitting 100 different hosts for sub-resources and you save 1 kilobyte per host, that's pretty attractive on many mobile networks and so forth. And yes, cached info would be great, but websites are really large. Our caches are not large enough to be as effective as we'd like. And yes, caching all that data, if we don't have to do that and we can get some benefit without it, it's nice.
So yeah, I'm certainly in favor of this work. This seems like good stuff. Just thinking about as Kyle was asking, if you say you fall back to HRR when you are worried about amplification, that it may be right in Quick, we may simply want to require that clients support this mechanism, thus avoiding that concern. What? No, it does because this is Victor's point. Is if the concern is bounce amplification, right? Then if the client comes to you and says they don't support compression, then what you do is you bounce them back with an HRR, thus forcing them to prove their IP. But another way to deal with that in Quick would be to simply require clients support this mechanism.
That is a good point. I find this on one way this is a good idea. On the other hand, there are some concerns about using compression.
Sure.
And some implementation like IoT devices might want to choose to not add compression for complexity reasons. So,
Yeah, so-
I'm split on that idea. Of
Yeah,
like,
I mean, certainly we wouldn't require this for run 3 because it's too late now. Anyway, this seems like good work, and I agree with Adam. That does seem like valuable, independent of cached info. I, for one, would like to get good performance the first time I connect to people, not just the second time.
Jana Iyengar, I want to say this is obviously good work, and I think we should have it. But this work is applicable to more than just Quick, and I want to point that out. I think this applies to TCP Fast Open also. The same amplification is possible with a TCP Fast Open cookie and a server that supports TCP Fast Open. It might be useful to point that out in the draft and not limit it just to Quick.
Aren't
they are tied to IP, but you can do the same thing that you. Well, I mean, so that a separate point, but this group should really engage and understand how TCP Fast Open works. Because with TCP Fast Open and TLS 1.3, you have a lot of the same problems that you have with Quick. I don't think they've been listed out anywhere exactly what a server should do and what a server must do for the right cookie and for everything else. It's not. Well, apparently, and we need the security experts and the transport experts to get together. But you have, me, and you're stuck with me.
Ian Sweat. I agree with John's point that I think this definitely helps TFO circumstances substantially. I mean, there are still considerations where it may or may not be necessary in that circumstance, but it's massively helpful. And in terms of cached info, especially mobile clients have much less available memory, much less available storage. Disk storage is not always really, it's not always possible to like persist when you like get swapped out and swapped back in, all these things. And so at least in Quick's experience, it's much harder to get resumption on mobile devices than it is on desktop devices. And so I think this disproportionately benefits like more limited devices, which is nice. Thanks.
Hannes, I think if you truly care about optimizing the performance, then TLS cached info obviously reduces that down to pretty much nothing. So that is sort of like a doubtful argument. And I agree with you when you talk to the first website, the first time, you obviously don't have that cached. And you may not want to cache, make your cache unlimited. However, the certificates are not that huge. Even on a mobile phone, you have a lot of storage. Browsers also cache a lot. So I don't want to hear that browsers can't do caching because that's what they do with websites all the time. Otherwise, we would be downloading megabytes with every web page visit.
So that's a good point, but I should note that with mobile phones, it's sometimes faster to send things over networks than to read them from cold storage. There are a lot of tricky concerns there, but Jana?
Jana Iyengar, not to derail the conversation here, but I do want to stress this point. The TCP Fast Open RFC says the server, cookie handling the server should do the following things in a cookie. The server is basically free to do whatever it wants in a cookie.
So I don't disagree with what you're saying here, and I thank you for raising that, and I really will be asking you to help out. But it's worth noting that any server which does that, any server which implements that way, and is also HTTP server, has some very, very serious amplification problems without TLS.
I completely agree. I wish we had a forum where, this room and the transport people could get together. I don't know what we'd call it, but it'd be nice to have a place where we could all get together. Yeah, like an engineering task force, perhaps.
All right, so I guess so we had a bunch of people that read it. There's seems to be some tension with if we adopted this, if it would hurt cached info. I guess Martin made a point on the list that we have to be fair if we're going to make it a dictionary out of it. But basically, I'm not hearing anybody saying that this is like the stupidest idea on the planet. So what I'd like to do is do a hum for adoption. And we'll obviously have to take it to the list, but I want to see, basically get a sense of the room here. So I'm going to ask a question after, I'm going to say, hum now if, and it's if you'd like to adopt, and hum now, if you don't. If you don't, I'd really like you to get to the microphone. I know that's scary, but if you really have an objection, it would be really great if you could get on the record. So are we good with that plan? Okay, good. So hum now if you would like to adopt this as a working group item. Hum now if you would not like to adopt this as a working group item. sold. So the sense of the room is that it will be adopted, but obviously we have to take the list. It'll take 2 weeks. We'll go from there, and I can provide you with more instructions about how to submit it as a working group item. Okay. So super, there he is. All right, cool. How do I make this full page? Ink. Ooh. Is that good? Can you read that? Okay.
Great. Hi, my name is Subodh Iyengar. I'll be talking about the delegated credentials draft and the updates that we've made so far since Sol. Next slide. So talk about the overview of what delegated credentials is, like some of the draft changes we made since Sol, and some of the stuff we did in the hackathon, which is kind of cool to share with you guys, and some of the open discussion points that are still remaining. Next slide. So it's a brief overview with cats. Everybody loves cats. So essentially, like there's a motivating example for delegated credentials. So you have a CDN with cat pictures in a less trusted location closer to the user, and you have a server in a more trusted location, which has the example.com certificate and the private key. You don't want to give the example.com private key to the CDN, but you still want to serve out cat photos closer to the user. Next slide. So you do something like a TLS offloading, where you offload the private key signatures to the trusted server. And this is done per client. So this incurs certain latency, often hundreds of milliseconds, can increase the time that the client takes to connect to the server. So, and results in cat photos getting there much slower. Next slide. Yeah, so in this case, it uses the examples.com's public key for the handshake. So next slide. So instead, the delegated credentials draft proposes a slightly different solution to improve performance, which is that once in a while, the server from a trusted location sends, or a server from less trusted pulls from the server a delegated credential, which is basically a signed public key, which is a delegation that, hey, you can act as me for a certain amount of time. So, and then next slide. And then instead of actually connecting to the server for each client, the delegated credential can be used to do a handshake completely offline from the server for a certain amount of time. So that's a general idea of delegated credentials. Next slide. So the major changes we've made since Sol are the following. So we've essentially trimmed it down to trim the fat. We've trimmed down to the bare essentials that are needed for delegated credentials. It no longer looks like a certificate, which is great. We changed the signature scheme, so we've added a bunch more stuff into the signature, which is kind of useful. I'll talk about that a little bit. We've cleaned up the draft to only have one option and nothing else. And we've added a requirement for a new XPOM9 extension. Next slide, please. So the bare essentials essentially are that, so previously we had like server names and stuff. Instead, now we have only what we need for delegations. There's a time, valid time, which is a relative time since not before, the certificate that is the end entity certificate that is signing the delegated credential. There is the public key, which is a subject public key information structure, which is serialized into this delegated credential structure. There's signature scheme, which the end entity certificate uses to sign the delegated credential structure. And there's a signature itself. I don't think we can get away. Anybody has ideas of like, if we can get away with not one less of these, that's great. Then that would be awesome. Martin?
Yeah, Martin Thompson, you could get rid of the scheme field.
Well,
but I wouldn't
I think we
advise
need
doing
scheme.
so. Yeah. Well, no, the type of the public key.
Well, we still need what scheme the public
You
key.
do. You need to know yeah. You need to know the hash for RSA. Yeah.
Correct. Yeah. So we still have the SPK, but we still need the scheme. Next slide, please. The other thing we've done is change the signature scheme significantly since the last revision. So we've added a bunch more stuff. We've added the prefix looks more like the TLS context string, and so that's intentionally done to prevent the same types of attacks that are on TLS context string, TLS signatures, remote offloading for those. We've added some more stuff, which is the protocol version, for instance. So you can scope delegated credential now to a TLS protocol version. So TLS 1.2 and 1.3, you could not have delegated credential for 1.3 or 1.2. Let me just finish this slide. Of course. Yeah, thanks. And now we also sign in the end entity certificate that is used to sign the delegated credential as well. So this has a nice property over proxy certificates or other delegation mechanism, which is that it is now cryptographically bound to the end entity certificate that was used to sign it. versus like relying on some cert path chain building or something like that to like decide which entity certificate. So one of the concerns is that let's say that you have the same public key on different certificates, then a proxy certificate path would basically, a man in the middle could trick you to choosing a different certificate than what you had intended to use for a delegation. So this prevents that kind of attack from happening. Then the signature scheme and the delegated, obviously the public key and the valid time as well.
So, I mean, this is a nitty nit, but I just noticed that you're duplicating the protocol version. So in 1.3, what we generally do is we say TLS 1.3, comma, blah. Right. And here you have TLS and then the protocol version.
No. So this is just this is the protocol version is the TLS protocol version structure. So this is.
I know.
Yeah.
I appreciate that point.
Right.
And I guess what I'm saying is that it seems like just in terms of making one's implementation easier, using the same, like at least our implementation, like we have like a function that glues TLS 1.3 on the front of everything else. And so since we only want this for 1.3 in an SS probably, like it'd be easier for me if you had this TLS, if they had two strings we used for different versions rather than having a string followed by a version.
Yeah,
it's really like not like a big deal, but it makes like very terribly easier.
Yeah, if you could put that comment up on the mailing list, that would be great. Thanks.
Adam 90 Google, you haven't forgotten the null byte at the end of the string, right?
Yes, so
Cool.
that is something. So that is something that that's something that we've actually noticed in the hackathon, and I'll talk about that a little bit.
Yeah, I had the null byte in red pen on my
Yep.
printout. But I was going to ask, maybe somebody should maybe collect a table of all these different strings that are used, TLS 1.3, blah, 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 and write that up somewhere.
Agree. Yeah, that would be great.
Melinda, sure. You probably get to this in a little bit. And I haven't read the draft, for which I apologize. So this is like a stupid question. But so you're signing the subcert with the private key associated with the server certificate?
Correct.
Is there a key usage issue here?
So I'll get to that in a bit. Thanks.
Adam 90 Google. We want every message to be signed to be injective. This is injective if the end entity certificate is an X509 because that's all length prefixed.
Right.
If we have extensions that allow other certificate types in X5 in TLS, then maybe that's not injective and maybe you want to length prefix it.
Makes sense. That's a good point. Yeah, we should add that as well.
Yeah. Martin Thompson, another nitty nit. The last two on here are in a different order to what they appear on the wire.
Fair point as well.
This is DKG. It's not just length prefix for the certificate, but certificate type, right? If we're allowing multiple certificate types, then you need the type and the length prefix.
Thanks. So yeah, that would be awesome. Thanks. Live issue filing, which is great. So then we cleaned up the draft significantly. We presented last at Seoul. We presented a bunch of different options, proxy certificates, name constraints. We cleaned that up. We think that this is actually significantly better than the alternative options that we have, and having our own structure allows us to do interesting things with it. So we trimmed everything and we just cleaned it up completely. Next slide, please. So this is gets the key usage issue that somebody mentioned. That basically we saw some comments in the working group last in Seoul and on the mailing list that, hey, we're uncomfortable with using the same key usage constraint but putting like weird constraints on it. So instead we say, hey, we require you to add a new X509 extension, which basically says that the X509 certificate allows you to use delegation, and if that is not present, then you're not allowed to use delegated credentials.
Richard Barnes. Is there a particular reason we did this as a new extension as opposed to using EKU or like the existing key usage stuff that's in X509?
Yeah, there's no particular reason. It's not that might be more difficult to extend the existing extension, but I'm open to comments and not very, very familiar with the X509 like process of extensions, but I know they're experts here. So
maybe we'll figure out which one's smaller and use that.
I bet then one more bit is smaller. Yes.
Yeah. Adam 90 Google, I would ask a CA which is easier for them to do.
Yeah, I mean that was going to be my
Exactly.
question at the
Yes.
end is like, do we have a chance of this actually being implemented? You know, Phil and Ryan and other people that might have insight to that.
Yeah, Rich Salza. Following on Adam's question, have you spoken to any CAs to see if they would support this yet?
Not currently.
I don't do operations, but from what I remember of various CAs, I think that putting things in anything other than the extended key uses is kind of really hairy.
Because
Okay,
you're already going to have an EKU for server, right? So
yeah, but you got to go. This is a key use.
It's a bit field though.
Yeah.
It's so that's kind of weird. Yeah. So the at least Mike talks to people with who work with the CA. Oh, great. Thanks.
Hi, Ryan Sleevey, Google. I spent a lot of time harassing CAs on standards and such. The extended key usage would have a particular challenge for client deployment due to the non-standard, widely implemented behavior of treating EKUs as a policy flow down. Meaning, if an EKU is present in an intermediate certificate, that is seen as restricting the type of certificates can issue. So it's certainly possible for client applications just to ignore all of that because you just need to look in the leaf cert to look at the EKU. And so from that perspective, it would be much easier to issue. But because of that ambiguity in terms of client behavior, it may be better to just go the extension route. That puts some greater complexity on the CA issuing side. Thankfully or scarily, many of them use the same 3 or 4 CA infrastructure products. So there is a small set of levers to push to get something like this in. But the EKU, that would be the thing that even I don't know what the risk of deployment for doing that as an EKU would be.
Yeah. So and to add to your point, like we've done this before with SCTs and things like that, where we've added new extensions, new semantics. So, and we've seen that has been successful. So I'm not too concerned about like adding. It depends on your relationship with the CA as well, as you brought up on the mailing list.
Clint Wilson, DigiCert. So from another CA perspective, EKU or a new extension, both totally doable.
Okay, thanks.
Adam Laney, Google. On a different topic, I noticed you only had 1 time rather than 2, and was it 32 bits?
I'm sorry, could you repeat the question again?
You only have 1 validity time rather than the usual 2, and
Right.
it seemed to be only 32 bits.
Right. So it's relative to the start time of the not before time of the certificate itself. So it's 30 bits enough for that, and it can be only restricted to 7 days from the start from the time of your connection. So
okay, thank you.
Yeah, Martin Thompson, one of the biggest concerns with this validity time thing is how you use it in reaction to clock skew on clients.
Yeah, so
I'm wondering if there's anything we can do to impose restrictions on clients who implement this such that we get more successful connections as a result. So can we say that clients can only do this if they've done NTP recently or rough time or something, done something to recover their time to within some reasonable period? I don't know what the right answer is here, but the whole time thing is sticky. Sorry, I just dropped a bomb.
I mean, so the way in which this introduces a sharper time window is that it reduces the thing to 7 days, and therefore therefore if the and therefore you can't run certificates very close to the end of the expiration time. No, because they wouldn't be valid before. No, because it starts from the dot before date. The opening window is the same.
So the issue with clients who have reverse clock skew is that if you want to allow for some amount of clock skew when you set this to 7 days, the instant that you issue that, the client that receives this has a reverse clock skew will see this time as being longer than 7 days, this period as being longer than 7 days long, and will reject the subset.
Yeah, so the interesting part about that is like if there are people who backdate their certs longer, then they will be more affected by the clock skew than people who don't backdate their certs longer. So it's like a weird projection. So I think the general point is that 7 days, we put the rationale in 7 days was that it's the same as a ticket lifetime interval in TLS 1.3. I think that we need to do more data spelunking to our own and search within our souls to figure out like what is the actual right time interval, or maybe if someone has a suggestion on an altered mechanism which is less susceptible to clock skew, that would be greater. That would be better.
Sanjay Mishra, Verizon. Quick question on the 7-day period. I didn't seem to remember in the draft as to after the expiry of the initial 7 days, how is the certificate or the credentials issued? Is it the client that needs to issue it? Because I don't see the draft talking about.
Yeah, so this is clearly like we've left this up to the implementation. I think that the clients don't need to do anything. Like the servers are the ones that interact with their whatever protocol they use between their backend service. So either it could be like the backend service pushes new certificates to their new delegated credentials to the less trusted services, or you could have a pull model where you have an API that exposes, does mutual authentication and stuff like that. But these are like internal details of how you deploy infrastructure, I think, and we've left this up to the implementation to decide what is the right thing to do, or another like working group draft which decides like we want to standardize something.
Philhan Baker. Yeah, when I heard 7-day lifetime, I mean, like basically if you want a 24-hour usage window, you need a 7-day lifetime. That's just the way that it is for all the protocols. The only thing that I'm kind of like thinking about now, looking at this, if you need the CAs to be involved in giving permission to issue this, why doesn't this just devolve into we give that other server a very short-lived cert?
So that's a very good question. So the critical point of this is that since the intervals is very, very small, we want to be able to control the infrastructure. So if we give a 7-day interval, basically, and we're not able to contact the CA authority at that amount of time, it's basically a reliability versus like a security trade-off right there, where we want to be able to control the shorter interval issued certificates rather than contact the CA every single time that we need to issue a new certificate.
Okay, so you're saying that regular contacts to CAs in your infrastructure.
Correct.
Yeah. Even though we have a really robust infrastructure, well, presumably Facebook has a CA that has a robust infrastructure, and you have a robust infrastructure.
Right.
But there is an issue with these two robust infrastructures.
Exactly.
Yeah.
Exactly.
Okay,
Yes.
I believe that, but
Yeah.
that's a useful data point for other discussions.
Adam Langley. If you want data on clients and clock skew and validation problems, you want to talk to my colleague Emily Stark, who knows an awful lot.
Thank you.
Going to Phil's question, Melinda Shore, going to Phil's question about getting in touch with having these issued by the CA. There's an economic reason for it as well. I'm with Fastly, and we're just dealing with a massive number of certificates, and if we have to get them from a CA, there's a cost associated with that. But other than that, no, okay.
Depending upon which CA you have a license with the CA that you should read.
If you complete your point, though.
Yeah, this is DKG. The other cost is that it bloats the size of the CT logs if the certificate authorities issue it, and the size of the CT logs is rapidly accelerating. We can't actually afford an infinitely sized CT log.
I'll add that this EKU flow down situation is maddening. It's really aggravating. So I think there's a very strong argument with going for a new extension rather than EKU. But aside from that, I think this is great. I'm really excited about it. So
Thanks.
Thank you.
Great. So going through the hackathon results, we a couple of people we came together and hacked on this in the hackathon, and it seems like it's implementable pretty good. We got some clients and servers interoperating with each other, like Fizz, which is ours, TLS Tris, Cloudflare's, and Pico TLS, which is Fastly's like implementation of TLS. Love for more people if they're excited to go implement this and figure out. So some of the things we figured out in the last draft is that the null byte, it makes it much easier to implement. Like if we can use this, what we ended up doing was that we ended up implementing it as a certificate type itself, and we didn't realize this while writing the draft. But so this is an interesting thing. While implementing it, we found this out, and so it would be much better to just match up with exact TLS signature schemes.
Piotr Sikora, Google. I just wanted to say that I think 7 days is a bit too long in the deployment scenarios you described, because this is untrusted location and attacker can, possess potentially your keys. 7 days is basically infinity, right? with no ways to revoke this.
I think that you could restrict 7 days is the maximum. You could restrict it to lower than that as well, depending on what you want. It's a maximum. So the clients enforce a maximum of 7 days. That's the 7-day interval here. So the question here is that what should be the maximum interval that the clients enforce as their validity interval? Because we've been stuck in the past with TLS 1.2 session tickets having no, well, they have a hint interval and session IDs have no interval at all of lifetime. So we thought it would be better to like essentially put a strong 7-day interval of max validity of the delegated credential. And you can restrict it to be lower if you want, and it's fine.
Yes, but in practice, most people will use 7 days.
If it's well-behaving client, the well-behaving client would respect the validity time and not cache it for more than 7 days. This is for non-well-behaving clients, mostly.
So the 7 days serves two purposes, right? One is it tells people do something smart, but the second is it asks the client to enforce it for you. However, in the case of in the compromise scenario, the attacker will just produce a bunch of will simply produce things with much longer lifespans. So one thing you might imagine doing, of course, is having the lifetime in the certificate itself, the max lifetime in the certificate itself.
Yeah, so that's the next
which I got up to say, but then I realized it was
like we only got one more slide, so
then I realized it doesn't help as much as you think it does, because the attacker just basically forges a big pile of subcerts up into eternity. And so I'm not sure actually that solves the problem.
Yeah, so
this is the same problem with all these offline signing attacks, basically.
So that's essentially the first question, which is, should we make it configurable via the certificate or some other mechanism where we should not restrict it to maximum of 7 days, but have the CA so delegated credential relationship define like how long the delegated credential is actually valid for.
Yavnir, so the real thing with the 7 days is that you can make it shorter, but the shorter you make it, the worse you make the problem of clock skew. So
there's a trade-off to be
it's
had.
either finding the right balance or figuring out that you can't win.
That's right. Yeah, so I think besides the 7 days discussion, there's another discussion to be had, which is also related to lifetime, is that where Kazuko pointed out that in the security considerations, we should really mention that just because you have delegated credentials does not mean you should not protect your key. It is so in the sense you can actually man-in-the-middle connections even in untrusted locations which is a more restricted case with that same key. So that's exactly equivalent to a full-term private key for those amount of
clip in a line after. Kyle Eckertz. I just want to point out, even if you do make this configurable in a certificate, you'll still have the problem where if someone gets access to a signing, can sign stuff, they can just sign tons of these delegated credentials for every different time period, no matter how small the time period it is.
Exactly.
Just thought I'd point out that if you had a key agreement that was based on Diffie-Hellman key agreement rather than a signature, you could do all this stuff for free.
So that would be per client, though, and we want to avoid.
Well, you can mint keys for each one of your hosts that is serving content, and
we want to do
additive
fresh keys for each connection.
You can do that. You can mint fresh keys. Yeah.
I don't think that it does.
Eric Nygren, and on the time skew one, if there's a way, as part of the workflow before using one of these, if you got the timestamp of where the client thought its time was.
Could you speak into the mic?
Oh, that if you had the client send a course timestamp of what its time was, then you could potentially use a much shorter time window than 7 days, because you could just fall back to a normal cert for clients.
Yeah. So in TLS 1.2, TLS has a mechanism. TLS 1.2 had a mechanism of indicating the client time in the client random, but I think that was removed for linkability reasons and things like that. So I guess that's an open discussion point of whether we should have, and that would help. Should we have clients indicate something rough rather than a fine-grained timestamp?
Right. Yeah. That's why I was saying a course timestamp there.
Yeah, that would be interesting, and I would love the working group's opinion on what.
So the sense I'm kind of getting is there are some dragons here that we'd have to work through. but I didn't really hear anybody getting up there and saying that they thought that this was an absolutely stupid idea. So can I get a sense, can you show me your hands of the people that have actually read this draft? So about the same as the other one. And I guess I'd like to just go ahead, because I was going to do it anyways later, and just ask the same questions about working group adoption. So I'll, yes, hum now if you would like to adopt it, no, and then get to the microphone if you don't. So is that an okay approach with you, Subito? You good?
I agree.
All right. And again, everyone should remember, because we adopt a working group item doesn't necessarily mean it's going to get done. If we start working on this and we're like, no, this really is horrible, the drafts can die. So, keep that in mind. So hum now if you think we should adopt this draft as a working group item. Please hum now if you think we should not adopt this draft as a working group item.
Yeah, this is Rich. I sort of don't see the point, because the fact that you want to use this in risky areas means you still have to take the same protection for long-term keys. And even if your exposure is just for a week, I just don't see that it solves any real problem.
Okay. So at this point, the sense of the room kind of seemed like a yes. So we'll take it to the list and see where we go from there. I think that there'll be some interesting security considerations that we'll need to write. So, thanks. Okay, great. So now we got about 10 minutes. Some of this will be 5 minutes, so this will go a little bit quicker. The basic idea here is, we're trying to figure out what to do with all these drafts that we get. So basically what we're going to do is show some abstracts. Hopefully you'll have read it. I'll ask you if you read the draft, and then we'll basically go through this hum process and then, move on to the next items. And this list is the list. I only have 4 drafts. There's really like 10 that have been waiting.
So Sean, Martin Thompson, just one suggestion.
Yeah.
When you ask the question, can you put the phrase hum now at the end rather than at the start?
Yeah, okay. You always correct me on that. I'll try to remember it eventually. So basically the idea is that I'm going to flash the abstracts up for 4 drafts. I'm going to ask 3 questions. Have you read the draft? If you understand what it's about, would you support adopting it? If adopted, would you participate in its development? Because I don't want to just adopt drafts and then we have like the authors working on it, because then we end up in this 10-year cached info problem. So we're trying to avoid that. We'll take a sense of the room here. We'll tell you what the sense is, and then we will judge consensus on the list, because we have to take it to the list. The first one is exported authenticators and TLS. It's a draft that
Things which don't get consensus in the room don't need to be taken to the list.
Fair enough. So the first draft is Nick's draft that he proposed last time, which is exported authenticators and TLS. Who has read the draft? All right, so that's like 10 people or so, including me. And let me go back to the questions. If you understand what it's about, would you support adopting it as a working group item? So if you understand what it's about and you would support adopting it as a working group item, please hum now. If you understand what it's about and you would not like to support it as a working group item, please hum now. So that's a yes. So we'll take it to the list. I would definitely say it was weaker than the previous 2, but that's probably because Nick didn't get to stand up and present. We did delegated credentials already. The next one is the TLS 1.2 update for long-term support. So this is this draft hasn't been presented in the working group, but it's a draft that Peter Gutman has wrote, which makes changes to TLS 1.2 to basically be a long-term support. Who has read the draft? Okay, we got about 10 again. Go back to the questions. If you understand what it's about, would you support adopting it as a working group item? So pretty much crickets. I heard a couple of hums way over in the corner, but it's pretty quiet. If you understand what it's about, would you not support adopting it as a working group item? Please hum now. Okay, so the sense of the room is no. And the last one is TLS server identity pinning with tickets, which is your ONS draft. Are you getting up to get to the microphone? Okay.
Can I have one fast hum, which is if this is taken to either individual or independent, are people going to complain? Okay. Is there people who are going to yell if this goes to the long-term draft is published by a different method than the working group. Thank you.
So subject to a suitable black box warning. I guess, to be clear, and now is what's important is that the community be clear about what we do not do and do not endorse. And as long as it has appropriate disclaimer, I don't object to this document being published with such a disclaimer and reserving code points under the new policy that you're suggesting as an individual submission.
Yeah.
Presumably informational.
Okay. The last one is the TLS server identity pinning with tickets, which is your own draft. Who has read the draft? Not a lot of people. Okay, well, I know what the answer is going to be to this one. If you've read it and you understand what it's about, would you support adopting it as a working group item? Please hum now. So pretty quiet. If you understand what it's about, would you not support adopting it as a working group item? So like no response. So that.
Yeah, Martin Thompson, I don't know what the answer to this one is.
Yeah.
We've talked about it.
Yeah.
I just don't know.
Yeah, and I mean, we got some comments last time too, so I'll get together with Rowan and try to figure out what we're gonna do. But it seems like the sense is we're not gonna be proposing it as a working group item. And with that, I thank you very much for a great session today.
Thank you.